blanket. Okay, so I guess you would agree that yes, trust is good, but control is better. How do you control? And the first step, well, now it's not moving anymore. Yes, the first step in controlling should be, as I mentioned before, to control the vaccination process. And this is, as I said, should start with the scope. What are you looking for? In what surrounding are you working? What are your aims? Of course, and then at the table you can have the wonderful ideas, but you have to put it into place. So when thinking about those things, you should always be aware of what can you really achieve by public veterinary or private public partnership. What can the services provide, or what services can be provided, and then of course, for the first point, in what epidemiological situation are we facing? Is it only a controlled area, or does it need the whole entire country? Are specific production cycles important? For example, for Germany, it would be turkeys. These are things, for France, it would be ducks. These are things you have to consider when you talk about that and talking about or thinking about the vaccination control. And be aware that yes, you might vaccine, and then the control is also tedious, and it was already mentioned by David Swain, it might become very expensive. And because expensive, if you're just rely on surveillance in a non-vaccinated population, you certainly rely on passive surveillance. So farmers, veterinarians, traders have to report suspicions. This is in vaccinated populations not possible anymore. So you need a structured sampling frame. You need when, how, whom do you want to test in order to verify, well, that the vaccine is working, you're free of, and you don't expect any transmissions. So please be aware, active surveillance is the way to go. And then when monitoring, and when you start more thinking about the process itself, you should be aware what type of vaccines are out there, what type of surveillance can you build on. We heard about the DIVA strategy, so which test can you already use? And then there is the vaccination distribution and the distribution and uptake. So as it was mentioned, do you have the capacity? Do you have those companies? Do you have enough material available that you can move on with the vaccination? Assessment of vaccine induced protection. And yes, there are a lot of studies out there. But we are always mentioning that you should know what type of virus is out there and how is the match. So you should know about the situation, and you should know about what type of poultry do you want to vaccinate. And then if you do ask yourself, how good was your vaccination? What type of marker do you use? Can you standardize that in order to really verify different vaccination protocols? So vaccine-induced protection, yes, should be monitored, and you might want to centralize it to get an idea about what is done. And as this first step, it's here last, you should do experimental studies, and we we try to push for not only experimental data in the lab, but also going for field studies. This was controlling or surveilling the surveillance for the vaccinated flock. How about what are you doing in order to see whether this virus is still out there? Of course, with a vaccination, you like that the virus, it might enter a flock, but the spread within the flock and in particular between the flocks should be low. So this is mentioned by the R0. And I mentioned this is not possible to monitor with passive surveillance. In the first days in Europe, there was the idea to use unvaccinated sentinels. We know it's not very straightforward. The approach has the limitations. So, and using the RT-PCR protocols, it's really good and fast in order to find detected animals. And we consider that, yes, how many samples do we have to analyze? Always recommended to go for a targeted monitoring program. So look at the sick animals. One word would be the bucket sampling. Environmental sampling is challenging and often not really straightforward, but it might be helpful if we are working on wild birds. And then here, this just should again highlight serology is basically something that tells you what happened in the past, and was also mentioned low path avian influenza virus other than H5 and H7 are interfering with this concept and might give you the wrong impression. So the take-home message, direct surveillance, virological surveillance is the most or the best way to go. Okay, control, but then again, yes, you like to have a good system in place, but please be aware that you certainly have your pitfalls and some, so you might not overstate what you're doing, and you should be aware that you should look at the situation you're facing and not just doing what everybody started with. So we face often the problem, yes, that people are trying to boost it very often and think, yes, this is the way to go. However, you should be aware that it's not enough just to put a lot of vaccine in the animals. This should be done thoughtfully, and it was already mentioned, maternal-derived antibodies is the key here to prevent successful vaccination of young animals. In additional, but it is often said, yes, that if you follow vaccination, you enter into an endemic situation. Well, I tried to convince you that if you are thinking about how to prevent this silent spread, then you can circumvent that and be successful with vaccination. This is just to highlight that in Europe, we always see that poultry infection are tightly linked to wild birds. So wild bird surveillance, this is just that it became endemic. So wild bird surveillance is giving you an early warning system, and of course it will give you the opportunity to have an early warning, an early warning what might happen. Yes, excess incursion from wild birds seems to be possible. But then, of course, this is just, well, time is running. Of course, you can also then think about other strategies in order to limit the virus burden out there, but this is something we might think of in the future. This is basically the take-home message, and I like to finish with this wonderful picture that you should be aware. You should be able to look underneath the surface of the water in order to see that what you have under the vaccination blanket. And with that, I'd like to thank you for your attention, and I hope that gave you some information that might be useful for you. Thank you very much.
Thank you, Chris. Really, muchas gracias, Chris. Apreciamos muchísimo que nos hayas acompañado y te pedimos si podés estar para la sesión de la final de las preguntas. Si podés quedarte ahora, sería un placer.
Yes.
Y para la sesión final, seguramente que vamos a coordinar David y mi persona, seguramente habrá preguntas. A continuación, vamos a recibir, señor presidente, doctor Scheer. Voy a presentar al doctor Zahak de Witt, que va a hablar de las vacunas, perdón, lo que hay que hacer en vigilancia y ventajas y desventajas de los diferentes sistemas. Doctor Zahak, por favor, adelante.
Thank you. Well, dus...
Perfecto.
Can you see my screen?
Yeah. See.
Okay, great. Thank you. This presentation is about the available commercial available tests and what are the advantages and disadvantages of these tests under the present situation. I guess you all know Table 1 in the terrestrial manual of WOA. It's giving a very nice overview of the different kind of tests for the different kinds of situations, but it's not really focused on the situation that you are going to vaccinate for age 5. So we try to give an update in the coming slides. And we have different goals or potential goals for the use of AIV diagnostics. You might be willing to show that your flocks are free, or you might be willing to show an infection or check the take of vaccine, or maybe you would like to estimate the level of protection that's induced by the vaccination, or you might even have another reason. Well, we have to consider that for all these goals, we have different factors to consider. First, what kind of host species are we talking about? Is it turkeys or chicken or duck? Are we talking about vaccinated or non-vaccinated flocks? And if you have vaccinated, are you using a whole virus vaccine or maybe a DIVA vaccine? We might talk about, an epidemic situation, but maybe also endemic. And maybe your flocks are not only dealing with H5 or H5 vaccination, but also with other types of influenza, like, for example, in many countries, H9N2, which is not a problem in the Americas, but it might be in H6 or whatever. And if tests are going to be used, we have to know that they are properly validated for the purpose that you would like to use it for. But if you go for virus detection, there are on the commercial market already point-of-care tests, the antigen capture immune assays. Most of them have been developed for the human market, so validated on human strains. And we know that their sensitivity can vary, quite a lot, but on average, sensitivity is not very high. Quite often 3 to 4 logs lower than, for example, virus isolation. So if you're going to use them, they are mainly recommended for use on samples that are expected to be strongly positive, like in an acute outbreak. With the PCR, there are several PCRs on the market, partly based on conserved genes, like the M gene. Part of them are subtype specific, like H5 PCRs, and there are also some commercially licensed based on the neuraminidase subtypes. But again, as for any other test, it should be properly validated on real material from clinical birds, and not just in the laboratory with some ideal samples. Sensitivity of the PCRs can be very high, and then we might discuss about the relevance when you have a CT of 39 that might not be, that doesn't fit with an acute infection. It is due to the variability of influenza viruses, even in the conserved genes, like the M gene and the nucleoprotein gene. It's still important to have a continuously monitoring whether the new strains are going to be detected by the test that you use. And there have been some very nice papers showing that a combination of 2 conserved genes might even be best to have the highest sensitivity. A big advantage of the RT-PCR, basically you can use them for any species. For antibody detection, it's more complex. The ACA-GL immune diffusion test is maybe not the most modern test, but it can still be of use. These tests do not make of these antigens are influenza A specific, so no difference between different subtypes, but they are aimed for precipitating antibodies, making them suitable for chicken and turkeys, but not good or not suitable, for example, for ducks. So these tests, they can be useful in detecting acute infection, but on the flock level. The Him activation inhibition test is a subtype specific, suitable for all species. However, when you use chicken red blood cells and you have a non-chicken sera, you need absorption to prevent non-specific agglutination or potential non-specific agglutination. You can have the complication by potential false positives caused by steric inhibition when the tested serum contains antibodies against the same neuraminidase as that's what's in your H antigen. So, for example, if you would have an H9-2 infection and use an H5N2 antigen, you might have reactions in your H5 test because of the antibodies against the N2. So it is advised to use 2 antigens with different neuraminases for every subtype of the hemagglutinin, or to use an H antigen that's based on the recombinant antigen, so no neuraminidase involved, or to have a protein, the H protein that lacks, it is purified. An advantage of the HI test is that it gives a strong correlation between the level of antibodies and the level of protection, at least when you use a homologous antigen. So when your antigen is close to the field strain, you can predict the level of protection. Most laboratories will use ELISAs. Well, there are a number of ELISAs on the market, part of them based on whole virus, part of them based on, for example, nucleoprotein, and there are also subtype-specific ELISAs on the market, like, for example, for H5. Part of these ELISAs are indirect, so that means that they are not suitable for all species, but based on the conjugate, for example, only for chicken and turkeys. There are also blocking ELISAs on the market, and they can be used for any species. Due to that, the ELISA does not detect, let's say, only neutralizing antibodies or protective antibodies, and there is not a good correlation between ELISA titer and level of protection. If you look at the current H5 vaccines at different categories, and we have different kinds of tests, basically what we have to do is to find a suitable combination to be able to discriminate vaccinated from infected flocks. Well, this is a kind of table that gives you a kind of overview, an overview to be able to check for the freedom of subtype H5 infections or vaccination, and also to be able to check for the success of vaccination. If your field situation is that you do not vaccinate and there are no other influenzas involved in your flocks, there are a lot of tests which you can use to show that your flocks are free. This is the most simple situation. When you do not vaccinate for H5, but another influenza virus is in your flocks, you do have interference. That means that some of the tests will already be positive by the other subtype, So it's then not possible to show that your flocks are free of H5. Still, the HI test for H5 is still useful, as long as you take care of the potential steric hindrance by the neuraminidase. The H5 ELISA is still useful, and you can go for virus detection. If you are vaccinating for H5 and you use a whole virus vaccine, that means that serology will be positive. So you cannot use it anymore to show that you are free of infection. So you have to go for the virus detection. If you use an H5 vaccination that's based on DIVA, and there are no other influenzas in your flock, well, that means that the HI test for H5 will be positive due to the vaccination. The whole virus ELISA will be positive. The H5 ELISA will be positive, so they're not suitable anymore to show that your flock is free. But for example, the NP ELISA is still very suitable, and you have the virus detection methods. If you vaccinate with H5 using a DIVA vaccine, but you also have another type of influenza in your flocks, again, serology is not useful anymore to show that your flock is free of H5, then you need the virus detection methods. If you would like to check the level of take of the H5 vaccination, just see if they become positive or highly positive. Well, serology is the way to go, but especially the HI test or the H5 ELISA or the whole virus ELISA, because an NP ELISA in this case is not useful. If you would like to estimate the level of protection against the H5 challenge, and then the HI test using an antigen that's close to the field strain is the best test to be used. So the take-home message is that based on the different situations in the field, some tests might be perfect, some tests might not be useful, and some tests might be, well, the use might be complicated, but for any situation, DIVA testing usually presently commercial available test is already possible. More tests are always welcome, but we don't, well, the tests that are available are already what we need. But however, like I said, the number of options you have depends on the field situation. Do you have other influenza strains? Yes or no? And what kind of vaccine are you using? And with that, I would like to thank you for your attention.
Muchísimas gracias, doctor Zahak, por su presentación y su tiempo para ayudar a las Américas y colaborar con toda nuestra región. Nos gustaría que nos pueda acompañar al final de la tarde en la sesión de preguntas, que seguramente habrá algunas preguntas para usted. Le agradezco muchísimo. Y ahora quisiera darle la palabra al doctor Unalan Pavad de OFLU, que va a hablar de las metodologías y protocolos para la identificación de influencia aviar en animales vacunados y no vacunados, en poblaciones vacunadas y no vacunadas. Unalan, por favor, adelante.
Thank you. I'm Gunalan Pavade. I'm going to give a presentation from the basis of OFLU network. So there will be two parts. I'm going to concentrate on the first part on the existing methodologies and protocols for the detection of avian influenza virus infection in vaccinated and non-vaccinated populations. And the second part will be on avian influenza matching pilot project. Could you see the slides?
No,
because
Gunalan,
I see
if you wish, I can share it from here.
Yeah, I think that was the idea, to share the presentation.
Yeah. Yes, just in case, but as any other people, just give me 1 second. There you are.
Okay, next slide, please. Okay, so just I will start my presentation with regard to give you an overview about the OHA standards on vaccination. So we have two standards, one the terrestrial code, which recognizes the vaccination can be used as an effective complementary tool as a part of a disease control program. So countries that use vaccination will not lose the status of their free status or zone if the provides that surveillance supports the absence of infection. In all vaccinated flocks, tests should be performed to ensure the absence of virus circulation. And also the test has to be repeated in accordance with the risk in the country. They also have to provide evidence of vaccination program. And also we have another standards that provides internationally agreed diagnostic tests that could be used by the laboratories worldwide. So these provide standards on the requirements of vaccines. Next slide, please. So in the previous presentation by fact, you see these slides as we say. So these are all the test methods that are available for the diagnosis of avian influenza and their purposes. So as mentioned in the previous presentation, we give the detailed procedures. So we have various test procedures which are available for the diagnosis and mainly for the detection of the agent, virus isolation, and real-time PCR are most preferred methods. As you can see, it has got triple pluses, which means it is recommended for their purposes, and those with 2+ is recommended but has limitations, and 1+ are suitable in very limited circumstances. So you can see here for the detection of the agent, the virus isolation, and the real-time PCR has got the maximum recommended purposes. And for the detection of the immune responses by serology, mainly we have the HI and also the commercial used ELISA test. Next slide, please. Okay, so now I will move on to the approaches to the differentiation of infected from vaccinated animals. So, which is called the DIVA strategy. The DIVA strategy has been put forward as a possible solution to the eventual eradication of hypopathogenic avian influenza, mainly the subtypes H5 and H7, and also some low pathogenic avian influenza, without mass killing of birds, and also to take care of the economic damage, especially in developing countries. So this strategy has some benefits of vaccination because there will be less number of virus circulating in the environment, but the ability to identify infected flocks would still enable the implementation of having countries implementing additional control measures, including the stamping out of infected flocks. So broadly, the DIVA strategies use one or two broad detection schemes within the vaccinated population. So as I mentioned in the previous slide, we have the virus detection, the detection of the influenza virus, which is called the virus DIVA, or the detection of antibodies using serology, which is called the serological DIVA. To use serological DIVA schemes, vaccination systems should enable the detection of the field exposure in vaccinated populations. As we mentioned, there are several DIVA systems are available. There are some systems are validated, but still many of the systems as per the publications are yet to be validated in the field because this is a new field and not much countries are having experiences. Next slide, please. Serological DIVA. To use serological DIVA schemes, vaccination systems that enable the detection of the field exposure in vaccinated palms should be used. There, as I told you, there are several systems are there. So we can see the first, the use of a vaccine containing a virus of the same HA subtype, but a different N from the field viruses. So antibodies to the N of the field virus acts as a natural marker of infection. So through this, we can say the vaccinated, identify the vaccinated population. The second serological DIVA options is the use of vaccines that contain only HA, that is replicating or non-replicating recombinant vaccines, which allows validated classical AGID or nucleoprotein or matrix protein ELISAs can be used to detect antibodies indicative of infection in vaccinated birds. Finally, the third category is through inactivated vaccines. a test that directs antibodies to the non-structural viral or M2E proteins has been developed. So there are category 3 systems that are to be validated in the field. Next slide, please. So here, when I say a DIVA compatible HI vaccine, we indent a vaccine that stimulates an immune response, ideally only against the HA protein, so that in case of infection, vaccinated birds will generate antibodies against the rest of the viral proteins like NS1, NP, matrix, etc. So these antibodies will be detected by in-house or commercial ELISA kits, meeting the requirements for a differentiation of vaccinated from vaccinated and infected birds. Next slide, please. So on the market, there are several technologies available for HPAI vaccines. So as you can see in these slides, we have the vectored HVT vaccines, vectored ND vaccines, DNA vaccines, subunit vaccines, self-amplifying RNA vaccines, for which a serological DIVA strategy is applicable, as all these vaccines stimulate antibodies only against the HA protein. So any commercial kit directed against antibodies targeting the NPM proteins will work, but also ELISA kits directed against antibodies specific for the circulation of NA in the region, like N1, will also work. Next slide, please. So now we should consider that also traditional vaccines like the whole inactivated virus vaccines that are successfully used in many regions of the world can be used in combination with a serological DIVA strategy. Nonetheless, these vaccines are compatible with fewer assays. In fact, in this case, these vaccines will induce a response not only against the HA protein, but also against the NA and the NP or matrix proteins, limiting the number of serological options to discriminate infected from non-infected birds. Next slide, please. So you might have heard during the meeting about the Sentinel surveys. It is also a DIVA-like strategy to identify, which is called unvaccinated sentinels. So the Sentinel surveys, the use of Sentinel birds and the close monitoring of the flag status does not closely fit the definition of a DIVA strategy, but these methods can be used to monitor vaccinated flocks. If Sentinel surveys is to be used, a certain number of unvaccinated Sentinel birds, typically 1%, should be kept and appropriately scattered in the vaccinated flocks and tested by both virological and serological methods. However, there are a lot of practical issues. Nowadays, we are seeing without good compliance of farmers and a proper management system, the presence of Sentinel birds in the flock may facilitate introduction and transmission of hypopathogenic avian influenza virus in this group of birds. And also, it is logically challenging to identify animals when the Sentinel bird is introduced in a large flock. False positive serological results are not uncommon, so it makes the interpretation difficulty and unnecessary disruptions of trade. And also, with the low pathogenic avian influenza, there are cross-reactivity of antibodies for low pathogenic avian influenza. Next slide, please. So for a very viable DIVA strategy, it is actually 4 criteria should be considered. That a practical companion diagnostic test should be available, and a strategy that is validated for fitness for purpose, and a strategy and procedure that is internationally recognized. And also, as we hear from Dr. Lesin's presentation, the trading partners should accept procedures and accept the vaccinated product. So all these 4 criteria always allows a viable DIVA strategy. So here I just compare from the publications quoted here. So we are trying to compare the heterologous NA strategy and the subunit strategy, where in the heterologous strategy, there are some criteria, but there are some limited field experience, yes, but more work is needed. And also when coming on to the subunit strategy, it's a viable strategy, potential, but also needs more work. So the next slide, again, I'm comparing the available strategies for DIVA from vaccinated animals with their advantages and limitations. So you can see mainly the sentinel birds, recombinant subunit vaccines, heterologous NA vaccines, and the differential immune response against protein. So here, just explaining the procedures, as I already explained in my previous slides, what is the procedure and the vaccines used on all these cases. So under what all the tests available, even in Dr. Sejek's presentation, we have already heard about the test used for this kind of using the DIVA strategies. And you can see there are advantages as well as the limitations. Some have low cost and some have time confusing. There is efficacy in providing, and some the test sensitivity is yet to be validated. So that is also one of the things when has to be considered when using the DIVA strategies. Some are conventional inactivated variants are used. There are also the risk of false positive due to the presence of protein combinant from various procedures. So this provides an overall review about what are all the DIVA strategies and what are all the pros and cons of using the DIVA strategies. Next slide, please. So as you can see, the serological sampling is more time consuming than virological sampling. Deaths are particularly susceptible to other types of avian influenza, so it needs to be taken care. Organic farming, free range, and backyard birds at higher risk of exposure to other non-HPAI N6 NX avian influenza viruses. So this needs to be taken care. Heterologous boosting strategies with the different vaccine strategies, technologies might limit the number of assay options. So to conclude, the next slide. So to conclude on the DIVA, there are many different vaccine DIVA strategies have been proposed for avian influenza viruses, but they all rely upon several key elements and needs validation procedures still to be outlined. DIVA viral serological testing might be one component, but suffers from being relatively insensitive and subject to false positive and provides virtually no information on the status of infection in the last 2 weeks of your life of your vaccinated flock. So I think this point was also presented by Dr. Lesims, as you can see. And the negative DIVA serology on a flock basis does provide some information, but it is likely there will be many false alarms when using it because the test available rely on detection of antibody to NP, which is common to all influenza viruses. All DIVA vaccine requires a sensitive, specific, cost-effective companion diagnostic test that can be run on a large number of samples. Sufficient scientific research must be performed to show that the test has a fitness of purpose. Next slide, please. So the other methods that can be already also discussed, the surveillance should be multi-layered and risk-based and targeted rather than relying on random samples to detect infection at a certain level. I think this point was also told in this meeting by several presenters before me. Routine deadbird testing, but it is also important to establish appropriate sample numbers for flocks of different sizes and existing background mortality rates. Surveillance system that demonstrate infection in flocks is not being transmitted. So I think this is one of the strategy the experts are discussing to do this at present. Next slide. So I'm going the European Union regulations has been published, which provides the conditions, what all the surveillance should be used in case of an emergency vaccination. As you can see, the burden of testing when vaccination is applied. So this is there in the website on the European Union regulations. As you can see, laboratory surveillance by collection of samples for virological testing shall be implemented every 2 weeks in the establishment where emergency protective vaccinations has been carried out to detect occurrence of infection with the pathogenic avian influenza field virus. The surveillance has to enable detection of prevalence of infection with the hypopathogenic avian influenza virus in the vaccinated establishment of 5% or less with a confidence level of 95%. So moving on to the next slide. So we have the preventive vaccination. So here you can see there should be a weekly virological representative sample of dead birds collected within 1 week. So this is the conditions, specific conditions when using for the preventive vaccination of hypopathogenic avian influenza. Moving on to the next slide. Again, the preventive vaccination. After the start of the vaccination, the following active surveillance has to be carried out by the official veterinarian in vaccinated establishments at least every 30 days to detect occurrence of infection with hypopathogenic avian influenza field viruses. Then a collection of representative samples for laboratory surveillance by serological or virological testing to enable detection of a prevalence of HPAI virus infection in the epidemiological unit of 5% with a confidence of 90%, using appropriate methods and protocol for early detection of the virus has to be carried out. So next slide. So this is an example to show you how a preventive vaccination quoting Italy, where a densely populated poultry areas where the samples have been collected, the number of holdings and the number of animals and the cumulative number of holdings, where we have to collect 5% prevalence for a 95% confidence interval. So if you see it on a monthly basis, they have to collect 20,000 samples to be tested on a monthly basis. Then there will be, in addition to this, the weekly testing of carcasses. So when we are having the vaccination, there should be a challenges for the sampling capacity and also to diagnostic capacity. So this should be noted when we are using the vaccinations. Next slide, please. So now I move on to the next presentation on avian influenza matching project. So as I told you, many countries are now exploring what all the vaccinations, and we have heard from during the meeting that all vaccination used should be updated according to the circulating strains. So with this in mind, AFLU has embarked on this project. Vaccination against hyperpathogenicity avian influenza is already being used in countries where viruses are endemic, and inactivated vaccines are economically cost-effective, so expected to be widely used in the region. Antigenic heterogeneity and drift can potentially reduce the effectiveness of vaccines in protecting against disease and shedding of virus from infected birds. So it is quite essential to provide information to stakeholders on the antigenic characterization of currently circulating avian influenza viruses so that they could select an appropriate vaccines for poultry and use it in conjunction with other information. So there is a real need for real-time monitoring for giving yearly warning updates to vaccine state teams. At present, there is no scheme globally. What is happening in different regions, only in certain countries they do it, but we don't have this information publicly. So AFLU has embarked on this project. Next slide, please. So as you can see in this slide, we have indicated a timeline. This is a pilot project we have initiated just for the H5 clade 2344B. So a couple of laboratories, the reference laboratories are involved in the generation of panel of standardized poultry sera in collaboration with other reference laboratories. So then there will be a selection of representative contemporary viruses using harmonized antigenic characterization. And then we are planning for an antigenic characterization map using cartography. So, and there will be a first report in April 2023 presenting the antigenic diversity of the currently circulating H5 viruses. So this is a project in progress, and you will hear from AFLU about the progress of this project. So there, next slide, please. So just to conclude this project, so there are some barriers and solutions that also need to be considered in the implementation of this project. So because we want a timely reporting of all the outbreak events, the surveillance informations, the sequencing informations, and the sharing of virus isolates from different regions. So this all needs to be there so that we can give a good report, and also the solutions. So that's why we have the AFLU. In AFLU, we are trying to create networks. We are trying to collaborate with various national, regional networks so that by this we can get all the needed reports, surveillance information, and also to improve the genomic sequencing capacity so that this project can be benefited through sharing. And so, as I told you, the UK reference laboratory and the Italy reference laboratory are leading with generating a panel of sera and omelets. So this will serve as an off-flu standard for the antigenic characterization of off-flu circulating avian influenza viruses, so that the other off-flu laboratories can assess for the assessment of avian influenza virus evolution. The outputs will be antigenically mapped by the Royal Veterinary College London using chromatography. Reference sera panels will be shared with the partners to expand geographical representation, and the results will allow for the continuous monitoring of antigenic changes in currently circulating avian influenza viruses. And last slide, and I would like to acknowledge our reference centers colleagues from Italy, USA, and Dr. Zavila and Dr. Lesims for contribution for this presentation. So from you are welcome to visit the Offlu Network website, www.offlu.org, for more information, where you can have regular updates from the that is received from the parent organizations, also the technical advice and protocols for many other useful links. And also, if you want to reach out to Offlu, you can write to the secretariat at offlu.org. Thank you.
Muchas gracias, Unalan, muy amable por tu tiempo y por acompañarnos. Me gustaría darle la palabra ahora al señor presidente, doctor Jacques Schier, para el punto siguiente de la reunión. Jacques, por favor.
Thank you, Luis. I'm just going to do a quick recap of what we've heard so far from our 6 speakers. Dr. David Swain set the scene for what we're seeing around the world for HPAI circulating virus and what has changed with this current H5 strain, and what our challenges would be presented to us based on vaccination administration and expense. Dr. Les Sims went into depth about factors worldwide that may prevent the use of vaccines, specifically trade barriers, but methods and processes that should be utilized if vaccine is needed to aid in eradication or deal with endemicity of high-path AI. He also discussed challenges and processes to overcome these challenges to vaccination. Dr. Erica Beckman gave us, again, challenges to vaccine availability and its use in the field. She introduced and examined vaccine types and platforms and routes of administration for different strains in the field and use and efficacy for high-path AI. She also discussed levels of protection and data around different types of vaccine. Dr. Christian Gould, I hope I said that right. I apologize if I butchered your name, sir. He spoke to us about high-path AI surveillance and to determine if virus is circulating or not, and surveillance methods to determine virus presence in the light of vaccination or non-vaccination. Also, evaluation how effective your vaccination procedures were, as well as the safety of your procedures. Dr. Sak DeWitt talked to us about surveillance tasks and what we would have to do with commercially available tests, advantages and goals for AIV vaccination diagnostics, and based on fit-for-purpose needs. Both virus detection and antibody detection tests were reviewed, as well as tests to differentiate vaccinated from an infected flocks. Dr. Gulen Pavati went over the WOA standards for vaccination and differentiation of infected from vaccinated birds in the field, and DIVA available strategies based on vaccines strategies, pros and cons, and DIVA complementary efforts. That's a quick recap of this morning's talks. I look forward and thank the speakers that were on today for those 6 talks, and we look forward to this afternoon and the question and answer period at the end of this session. I'll turn it back to you, Dr. Barkos, for this afternoon and for directions going forward. Thank you, sir.
Muchas gracias, señor presidente. Los esperamos en 2 horas. Pueden empezar a conectarse a las 13 horas del este. Y bueno, afortunadamente hemos tenido 300 participantes y la capacidad del Zoom es de 300. Y bueno, los que no han podido conectarse lo pueden ver en vivo y en directo en nuestro sitio web y continuar la reunión. Los esperamos por la tarde, así que pueden tomar un descanso ahora y los esperamos luego. Muchas gracias por atender esta reunión.
Hello, I just wanted to test my microphone.
We can hear you loud and clear.
Sound is good? Okay. Thank you so
Yes.
much.
You're welcome.
And just to check, I will share the screen, or you will display both versions.
This is upon you. I don't know, if you want, you can share your screen. If not, we can share. We also will share the translation version.
Okay, if I share, it might be easier, then I can move the slides and not have to rely on you, if that's okay.
Okay, it will be possible for you to, when you move to the next slide, say next, so the other person that sharing your Spanish version can move at the same time.
Oh, if you prefer to do it yourself, that's fine. I will just say next then. I won't share my screen then. That makes it easier for you all. Thank you.
Okay, thank you very much.
Leandro, te hago una pregunta. ¿Vos estás, yo estoy figuro como co-host en este caso?
¿Está con este perfil?
Sí.
Dame un segundo. Creo que no, porque tengo la opción de
Quedó
guardar
fuera.
host.
Dale, así ya habilito la que está grabando en inglés.
Okay.
¿Necesitan probar algo o puedo seguir compartiendo el anuncio de la reunión de México?
No, podés, tranquilamente.
Leo, creo que no me hizo co-host todavía. No sé si o no lo hiciste aún. Listo.
Hola Martín, ¿me escuchás?
Alto y claro. Sí.
Sí, Martín, ¿cómo haces para registrarte en la pantalla esa donde tenés que poner tu filiación? Yo intenté y no pude.
Lo que tiene que hacer es, no sé si tenemos nosotros hecha ya un slide para eso, inclusive.
Sí, aparecía un slide, pero
selecciona la lista de
era...
participantes.
¿Y dónde está la lista de participantes?
Abajo al pie dice Participants.
¿A dónde?
En la pantalla.
¿En
Que
mi
está viendo,
pantalla?
así es. En su pantalla de la reunión, abajo dice para mutearse, stop video, security.
Sí, y después dice participa.
Bueno,
¿Participants?
hace clic ahí.
Así, me aparece al costado.
Bueno, el primero que aparece es usted.
Sí.
A la derecha hay 3 puntitos.
A la derecha no tengo nada. Tengo, a la
Dice
derecha
mute,
tengo solamente...
mute.
¿Cómo?
Dice mute y a la derecha 3 puntitos.
Tenés que...
pero
hola,
tengo que abrir
Alejandro.
mute. ¿Cómo?
No, hola Alejandro, soy Leandro Barcos. Tenés que
Hola.
posarte encima de tu nombre y ahí se habilita un botón nuevo que dice mute y los 3 puntitos a la derecha. Posate con el mouse arriba de tu nombre.
Sí, pero vos sabés que no pasa nada.
Ok.
Sigue
Bueno,
mute y more.
Lo renombramos nosotros directamente.
¿Me registrás?
Sí, no hay problema.
Yo había intentado también por acá, pero bueno, no podía. Menos mal que te pesqué ahora, antes de que empiece la sesión. ¿Me pones como Fundación Prosaya?
En realidad queda como participante general, porque
Bueno,
son
como
las
quieras.
organizaciones que hay convenio, ¿sí?
Está bien, no, está bien.
Ya
Entonces
estamos.
ponelo como sea. Pero está.
Sí.
Che, muy buena el programa. A mí me hubiera gustado, y lo que falta de la tarde va a ser un complemento muy importante, porque lo que me parece personalmente que no ha quedado absolutamente claro es el tema del uso de los test DIVA o de la detección de infección en las poblaciones vacunadas. El alemán no fue muy contundente. Así que espero que ahora el de la charla esta de la tarde, este muchacho, no me acuerdo que es húngaro o algo por el estilo, lo aclare mejor, ¿no? Y el otro punto que me parece que era bueno el punto, pero no lo desarrolló en su totalidad David Swain, es el tema de las migraciones, ¿viste? Especies, rutas migratorias y especies. Porque eso puede explicar mucho del tema de por qué el este de nuestro país, digamos en la parte norte, inclusive Paraguay o Brasil, no ha sido afectado todavía.
Alejandro.
Sí, ¿qué tal, Luis?
Bien.
Excelente la reunión, excelente el programa, la selección de los tipos, muy oportuna. Te anotaste un golazo con esto.
Bueno, gracias. Te están escuchando los 125 participantes, así que
Bueno,
ahora
yo pensé que no.
vamos a... Sí, porque está abierta la reunión, pero no hay ningún problema. Bueno, sí. Vamos a continuar con las personas que van a empezar a entrar y en breve continuamos con la sesión de la tarde.
Empezás a las 3:30 entonces.
Sí, exacto.
Disculpa, no sabía que estaba todo abierto. Pensaba que estaba nada.
No te preocupes, está todo bien, no te preocupes.
Excuse me, if the moderator I had a question on my presentation. Are you going to advance the slides? I don't have the presentation in Spanish.
Hi, I'm Luis Barcos. How are you? Well,
How are you?
Fine. If you like to pass your presentation in English, you could do, and we will do at the same moment in Spanish. But if you prefer that we management the both in English and Spanish, it's up to you. You only you need to say us next, and we will change the slide. But we could do. It's up to you.
Okay. Well, just this morning's session, it looked like most of the presentations that I was seeing were in the Spanish. I didn't see the English PowerPoint version of that.
No, David, all the presentation are in English and Spanish. The issue is when you go up, when the presentation are in the screen, you go up and you could select the vista and you could go to the presentation in English or Spanish. Leandro or Martin, could you put any presentation? I will show you, David, the way
yes,
to do it.
But
yes.
We have to, well, you will share another one, Luis, so we can, there will be two presentations.
Martín, vos compartí una y Ana la otra.
Listo.
Yes.
I will go
David.
with Dr. Ketty. I will
Now,
put one in English. Just give me a second. So you can see my screen.
Not ready for me. They will come soon.
Compartiendo la carpeta.
Just,
Martín,
yes.
no
Sorry.
presentación.
Sorry. I was working with the other monitor, so let's go with it. Second. Here we go.
Okay, David, you see now, you go up in the screen and you could see, todavía no me aparece opciones de vista para los dos idiomas.
Now you are.
No. Okay, David, if you go up in your screen, you could see opciones de vista. Then you go down, 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 and you could see presentation ESP, español, o Martín Minassian. Martín Minassian, if you could change the presentation of Martín Minassian are in English. Okay?
Okay.
And
yes, I see that now.
Yes, and you could go in the interpretation downstairs in the same way, the original audio or English in the same way. If you select Spanish, select in language Spanish. If you select English, select the language in English too. This
right.
is the way.
Yes, I saw the English part, and so that wasn't the problem. It was just the PowerPoint presentation.
Yes, I hope that Zoom application will be easier and facilitate this more friendly way. Yes.
Luis, buenas tardes. Es Etienne. Entonces, cuando sea bien, puedo compartir la mía presentación en inglés y tú o no sé quién comparte su presentación en español y la participación elegían lo que querían. Ok.
Así, señor, así es.
Ok.
Incluso
muy bien. Entonces, voy a compartir la mía. Ok, gracias.
Tu presentación la podemos pasar nosotros si vos querés también.
Pero no, prefiero pasar mi mismo, porque es más fácil, más fluente, más fácil.
Te avisaremos cuando te toque el tiempo a vos. Ahora empezamos con Mía.
Okay.
Empezamos, primero va a empezar Mía Torchetti, después David, y luego venimos.
Y después el break yo.
Sí, señor.
Ok, a las 14:15.
Sí, señor.
Gracias.
Gracias, Etienne.
Voy a aprovechar, voy a hacer un recordatorio para que están participando. La idea es hacer una lista de participantes y, como les ha comentado el doctor Luis Barcos, vamos a compartir el video de esta reunión a aquellas personas que lo soliciten al correo de la representación regional. Igual lo voy a poner en el chat, ahí está disponible. Hay una cuestión, nosotros vamos a chequear que la persona que estuvo en la reunión sea la misma que está solicitando y viceversa. Entonces, por ejemplo, hay un participante identificado como iPhone que, si en el caso que nos solicite la presentación, no vamos a poder saber quién es. Entonces, estamos pidiendo por favor que se renombren, porque si no, no van a estar en una lista de contactos que participaron en la reunión a los que les vamos a poder facilitar la grabación. Igualmente les recordamos que las presentaciones ya están disponibles en nuestra página web.
Si me permitís, Martín, aclarar por cuestiones de seguridad y confidencialidad de los datos, la lista de participantes no se comparte, no se hace pública de ninguna manera. Es solamente para nuestro conocimiento y no, la política de nuestra organización no permite compartir la lista de participantes. Estamos a 3 minutos de comenzar con la sesión de la tarde, así que comenzaremos puntualmente con la primera presentación de la doctora Mia Torchetti en 2 minutos ahora. Solo un comentario para la sesión de preguntas al final de todas las presentaciones. Las preguntas se van a recibir por vía del chat, únicamente vía del chat. Las pueden hacer en español o en inglés y nosotros las vamos a traducir al otro idioma para los presentadores, para que las puedan leer y contestar. Se van a contestar en el idioma del presentador y con la interpretación simultánea. Martín, ¿cómo estás en el chat? ¿Vos con qué nombre? No te encuentro.
Claro, no estoy con Martín porque estoy con Eng Presentation. Me puedo poner a mi nombre, no te preocupes.
Gracias. Bueno, siendo las 15:30, doctor Jackshier, quisiera darle la palabra a la doctora Mia Torchetti para comenzar. Así continuamos con la sesión de la tarde. Mia, por favor, adelante con su presentación. Muchas gracias.
Okay, thank you very much. Really very much appreciate the opportunity to speak about the situation in the US. Thank you again to all the organizers and to the participants. Not seeing the presentation yet. There we go. I just need to get shifted over to the right version. And I will also silence my camera while I'm presenting just to avoid any network issues. Greetings all.
Dr. Torchetti,
Okay.
I am sharing the presentation in English you provided us. In case you wish to present from your computer, let me know and I will let.
Thank you so much. I see it now in English. Thank you. We can go to the next slide, please. Okay. I wanted to open with that this work could not be done without so many of our colleagues. This is, as you've heard from our morning speakers, this is just an ongoing and enormous event impacting us globally. We are leveraging real-time whole genome sequencing data together with available epidemiologic information to better understand how this virus is moving. And when spillovers into poultry occur, this gives us better insight into how the virus might be spreading. We have thousands of wild bird detections across 144 species in 49 states. Reassortments of this H52344B virus with North American viruses continue to predominate about 86% of detections. As I said, this is a collaboration, and without our NOLN partners, which is our network of animal health laboratories here in the US, our APHIS Wildlife Services, and of course, our great colleagues at ARS Southeast Poultry Research Lab, many of who have joined us today, we would not be able to produce this amount of work. Next slide. I wanted to just take a second, and I know that Dr. Swain already gave us a little bit of the perspective on outbreaks globally, but I wanted to give a recall of the event that occurred late 2014 into 2015, so that there might be a little bit of ability to compare maybe why we are seeing the situation we are seeing today. So back in late 2014, we did see introduction via our Pacific Flyway, likely through the Bering Strait, of the 2344 subclade C into North America. And this virus reassorted very quickly, basically almost upon introduction to our North American flyways, with a couple of North American neuraminidase genes, including N8 and N2. Next slide. And so upon the introduction of this virus, we did see spillover into poultry, initially along the Pacific Flyway, and then moving into the Central and Mississippi Flyways. We never saw this move into our Atlantic Flyway, nor did we detect it in wild birds there. And the panel on the left indicates our poultry detections in total, the number of flocks affected, the number of commercial and backyard, just so you can have those numbers in your mind for comparison. And then on the right-hand panel, what you see is the blue triangle represents that H5N2 that really predominated through the Central and Mississippi Flyways, versus the black colored areas are the previous H5N1, H5N8, and also a little bit of H5N2 along the Pacific. Next slide. So we were also conducting intensive wild bird surveillance during that time. Wildlife Services certainly stepped up and initially enhanced the surveillance right away once we had even the first detection. And in total, when we look at the period between December 2014 and July 2016, we had 53,470 birds sampled, but only just shy of 100 detections, and only 2 from June of 2015 until the last detection, which was December of 2016. You can see that on the right side of the panel. That was in Montana. Those viruses that were detected in 2016 were also that Eurasian North American H5N2 virus. But just generally speaking, trying to give you the sense of how little virus was actually present in our flyway during that event, so that you can compare it to what we're seeing now. And I've also got on the left-hand side there the total number of birds sampled by flyway. So there was intensive sampling going on. We weren't finding it for lack of looking. And so we can move into the next slide. That's the last slide I have, kind of covering the previous event. And you can move on to the next one. So now we're into the late 2021 to 2022 to the current event. This is a new site that Wildlife Services have stood up to better capture some of the wild bird surveillance. And so comparing those numbers that you just saw, and that was 2014 to 2016. So here, that was 53,000 samples. Here we're talking about 34,000 samples. And just drawing your attention to the comparison of less than 100 detections in wild birds from that previous event to what we're seeing today. We've got over 7,000 detections. And with fewer, the proportion of samples here is a little bit less than what we saw on the previous summary slide. So just to, sorry, that 7,400, it represents all IAV detections, not just high path. So just to be clear there. That's also to mention that it's a really heavy year. Influenza, the prevalence of influenza in wild bird populations does tend to wax and wane in multi-year cycles. And this is definitely, 2022 was definitely a heavy year, seeing about double the proportion of what we normally see for just influenza A detections in those wild bird samples. Okay, next slide. This is the current dashboard for wild birds as well. And you can see we've just colored the map completely. These are our wild bird detections with specifically the 2344 virus. And just a reminder up at the top there that this virus was initially introduced via the Atlantic Flyway. We have active links that we'll make sure that get shared for how to find this information. Next slide. So here are our poultry. Unfortunately, the map looks quite similar. We're minus a couple of states in there for our poultry species affected. This is the total outbreak, as you can see, and you can see the number of flocks and the number of states far exceeds what we saw in during the 2015 event. Next slide. Another distinguishing factor of this event compared to the previous is the spillover of the virus into mammals. And I'll just quickly state during the 2015 event, I think we topped out, at least for the US, at about 24 different avian species. So that was the wild species affected. And as you've seen for this event, we've got almost 150 species already of just birds affected, wild birds affected by this virus. And now also seeing spillovers into these mammals, which I know some of our South American colleagues have seen as well. For the US anyway, these do tend to predominate along the northern half of the country, but in that northern half, within that northern half, coast to coast detections. On the right side there, you can see that this is the animals are categorized and colored on the map by the type of species. So they use colors and shapes to distinguish the species. And overall, we are monitoring the virus for potential mammalian adaptations, such as the E627K. We do see it periodically, and that is not unexpected when the virus replicates in mammals. To date, we don't have any conclusive evidence of mammal-to-mammal transmission. The seals that were affected up in the New England area are a question mark. We don't have solid phylogenetic evidence, but it's really difficult to understand how the virus is spreading between those animals when you've got the birds and the seals clustered so closely together on the shores. Next slide. Okay, so we're going to go into kind of the overall phylogenetic overview, and I will kind of preface this section by saying this virus has really given us a run for our money. The ongoing analysis has continued to be very, very challenging because of the ongoing reassortment of this virus. So as soon as we get a pipeline going and we have good comparisons, it tosses another reassortment at us, and we have to break it down and incorporate something new into our pipeline to make sure that we're getting real-time accurate analyses of these viruses as they go through. I guess one advantage of those reassortments, though, is it really does help us very concretely in many cases say, yes, you've got independent introduction of a wild bird virus that has not spread anywhere else, compared to when we have those situations where there might be a highly similar virus, being able to give some more concrete information to the field so that they can follow up from an epidemiologic standpoint. Next slide. This is an overview along the bottom of the graph. I think I can't quite see it, but it goes basically from, I think, December to December. Yeah, December 2021 to December 2022. And this shows you a distribution of our main genotypes. And so you can see, as has already been presented by other colleagues this morning, that what we see in the poultry does mirror what we're seeing in the wild birds. And the interesting thing is there are some wild bird genotypes that don't seem to really do well or impact that many poultry. I refer your attention to the kind of gold color on the left side. The left side is wildlife, the right side is poultry. And you see that gold color barely shows up on the poultry side, and contrast that with, say, the green or the more brown orange colors, which are definitely more predominant on the poultry side. Next slide. This is just a very good visual, thanks to our Southeast Poultry colleagues, of some of the reassortments that we have seen. To date, we have really not seen any sustained reassortment of the neuraminidase, and that's very different from what we saw in 2015. It really seems to want to hang on to that N1 that it came in with. And again, even though we have, say, like a 2-gene or a 3-gene reassortment, it's not that simple either, because then we have multiple 2-gene reassortments and multiple 4-gene reassortments. So this virus really has given us a run for our money, but wanted to give you a visual of what we're seeing. To date, the matrix has not reassorted. That the matrix gene has also not reassorted. It maintains the Eurasian matrix gene. And the other thing I wanted to highlight on this particular slide is that all of the reassortments that we have characterized in the US have been a result of the initial introduction, or what we call the Newfoundland-like virus. We have not identified reassortments of any of the other. There have been other introductions identified into the US, both on the Pacific and the Atlantic flyway, but we have not seen reassortment of those viruses to date. Next slide. This is a little bit colorful, a little bit hard to see, but this represents some of the major genotypes we've seen in poultry over time. So time is along the bottom, the horizontal axis, and then flyway, and then state is on the vertical axis. And you can see how, and this would be normal, the normal ecology of influenza, where you have kind of a sublineage may rise up and then decline and disappear potentially from the area, and you'll see another one take its place. And that's kind of what we're seeing with this particular virus. Next slide. And this is another display or a visual for the same type of information, the most predominant genotypes by state. Anything with an A in front of it is our unreassorted virus. So that would be our Newfoundland-like virus with its original full 8-gene constellation that it came with. That's the A genotype. And then anything with a B is a reassortment of that A1 genotype. And you can see that some of these have done very well for themselves and have basically managed to move with birds and affect animals across the country. And again, here we have, I'm not sure I can see it, I believe pink is wild bird and blue are poultry. Next slide. So I just wanted to give a little bit of a closer view on the different major genotypes that we've seen. These are our unreassorted genotypes, A1, A2, A3. Again, these are viruses that we find in their native constellation. Initial introduction via the Atlantic flyway, A1, A2 also in the Atlantic flyway, and currently still remains limited to the Atlantic flyway. Initially, actually, A2, which is the virus that affected the seals in the Northeast, seemed to just stay very focally in the Northeast for many, many months. And only recently have we identified it further down the Atlantic flyway in the Carolinas. Another introduction was identified on the Pacific flyway. I believe this is also a virus that Canada has seen as well. Currently, it has been limited to the Pacific flyway. And again, we have not seen any reassortments of either A2 or A3. Next one. This is our genotype B1.2. This is North American PB1, PB2, PA, and P genes. This one was primarily focused in the Mississippi Flyway in the spring, but we had steady detections throughout. It maintained a fairly steady presence in the eastern two-thirds of the US, even into the fall, but had a wider range, generally speaking, but overall similar numbers of detections in wild birds and in poultry. Next slide. The genotype B2 is a good example of one that has declined since the beginning of the event. Had a very, very big splash, peaking in about April of 2022. This one is has a 2-gene reassortment, PB2 and nucleoprotein. And it was very, very predominant in the Midwest, the upper Midwest in the spring. You can see in the maps in the panels below, the darker colors represent more detections. This particular genotype had dropped significantly by June 2022 with only sporadic ongoing detections. Now we have a very low prevalence of the virus, but what appears to be a wider distribution in the fall. Next slide. Genotype B4, this is a reassorted A1 again, North American PB1 and NP. This one was interesting. It does look like it might have reassorted further north of us before we saw it. It was detected initially mid-April in the northernmost states. It quickly became a predominant genotype in the Pacific Northwest and then shifted down south into California. But it has decreased in the fall with only sporadic detections currently. Next slide. This is the one that has been kind of the most prevalent here in the fall, as you can see from the panel on the wildlife panel there. And maybe not surprisingly, this is also the genotype we have identified in Central and South America based on both publicly available sequence as well as samples that have been sent to us for characterization. This is a 4-gene reassortment and it had steady detections throughout the spring, expanding down into Utah, and then a new branch of this virus emerged in the fall, detected in Alaska and Idaho in June, and then across all flyways starting in September. And this remains currently our dominant genotype across central Mississippi and Pacific flyways, as well as Florida. And you can see the impact in the poultry as well as wild birds from these panels. Next slide. And this is just a zoom in a little bit on the same distribution that was shown initially. This limits the view from June of 2022 until December of 2022, just to again give that sense. And I believe that browny orange color is our B3.2 virus and the distribution that we've seen. Next slide. And as I mentioned, genotype B3.2 has been detected in Central and South America. The black that you see there would be our poultry detections, the name labels, and then green is our wild birds, and then purple is you can kind of see it scattered throughout. And again, this is just one major branch of our B3.2. It's just to give you an idea that we are seeing diversity in this virus, and it's not that there's like a predominant single virus that's out there taking over. So just wanted to, I thought that was a good visual for you. Next slide. Lastly, just to draw folks' attention, we do have 2 seal events, the New England seals on the left panel, and then a publication from our Peruvian colleagues in the right-hand panel. They are different types of seals. We've got sea lions in Peru, and we had harbor seals. And I forgot the other type of seal. All of a sudden, it just popped out of my head. But harbor seals in New England. I believe that's about all I have for you. Next slide. Just another shout out and thank you to all the people that have been working so hard in the field, in our laboratories, and our academic institutions, and our research institutions, and across USDA for working so hard to combat this virus. Happy to take any questions, or but that's all I have for you today. Thank you.
Bueno. Ahora le damos la palabra al doctor David. Perdón. David Suárez, por favor. Adelante.
Good afternoon. Appreciate again the opportunity to come speak with you about this topic, and hopefully we can hopefully kind of tie some things together that were brought this morning. Hopefully everybody can see the slides that we have that I'm sharing. I wanted to start off with this slide, which is talks about the clade system that we have for the goose Guangdong lineage, which I think is kind of important. As it's been described before, this virus has been circulating in poultry and wild animals for over 20 years now, over 25 years. And this virus continues to have antigenic drift in the hemagglutinin gene. And we have had to come up with this clade system to describe those genetic changes, with the idea that the original strain, the original goose Guangdong 96 virus was the 1996 strain, the clade 0 strain. And then this is radiated where we've had multiple clades, and then we've started to have subclades because the virus has continued to reassort and change. And the whole point of these clades is just like we have with human influenza, is that antibody to one subtype or clade is not going to be protective for all the clades. You're going to have a decrease in protection, maybe not a complete lack of protection, but certainly a decrease in protection. And now we're talking about the 2.3.4.4 clade, and we've even, again, have additional fifth order clade where we're talking about A, B's, and C's. So the virus that we had in 2014-15 was a clade C. We're dealing with the 2.3.4.4b here. The sequence difference is about a 6% amino acid difference between those two subtypes. Now, when we talk about vaccination for avian influenza, the point I always like to make is that vaccination can do a great job of preventing disease and reducing virus shedding, but it doesn't provide sterilizing immunity. You don't prevent the birds from getting infected, or at least if you give them a high enough dose, you won't prevent infection. And it's also important to recognize that antibody to the hemagglutinin protein is really the primary protection that you're seeing, and that if you have high levels of antibody targeted to your field strain, you're generally going to get very good protection. Does that mean there's no protection in the other genes? There is some protection with the neuraminidase gene, but typically it's difficult to get high levels of antibody to the neuraminidase gene to have effective protection with just the neuraminidase gene. So I won't say that it doesn't provide any advantage, but it's relatively minor. Now, when we have a live virus vaccine or a viral vector vaccine, cell-mediated immunity also plays a very important role, and it can add additional protection to the antibody to the hemagglutinin protein. But it's been difficult, and I'll mention this several times, that it's difficult to measure that cell-mediated immunity, and so we have to look at that very carefully because it's difficult to predict in advance. We don't generally see any protection to the internal protein. So although influenza viruses may elicit a very strong nucleoprotein antibody response, that antibody is not protective, and therefore it may be helpful for our DIVA strategies, but it's not going to be helpful for us protecting our flocks. And again, finally, although we see no cross protection between subtypes, so H5s only protect against H5s, they don't protect against H7s or H3s or any other hemagglutinin subtype. And remember, because of that antigenic drift, we may not see protection even within a subtype because they can change so much. This slide is just showing the X-ray crystallography of the hemagglutinin protein. We have the shaft and the globular head. Antibody to the globular head is typically the most protective antibodies that we have. So generally blocking that receptor binding site, preventing infection is certainly a way that the antibody is neutralizing or actually prevents infection. And therefore, we really want to make sure that we have antibody to that globular head. And again, antigenic drift can be a major issue. Now, when we look at, we're really in the age of biotechnology. So we've actually, and Dr. Spackman earlier talked about all the different types of vaccines that we have available. This is just kind of summarizing some of those. Now, these viral vector vaccines, or the using biotechnology, we have a lot of different types of vaccines available to us. Some of them are very easy to update. Other ones are more difficult or require more licensure issues. And generally the live viral vector vaccines are harder to license than, let's say, the killed reverse genetics vaccines or the baculovirus express proteins vaccines. Now, the advantages, again, to the live vaccines is they are providing both cellular immunity as well as humoral immunity, whereas the killed vaccines or the baculovirus express protein vaccines are only providing antibody to the hemagglutinin. So if you could have both, I think it's better to have both. But again, antibody by itself can be completely protective as long as we have high enough levels that are specific to the viruses that we're looking at. Now, I'm going to make the point, I know several speakers earlier made the point, is we want to match the hemagglutinin to the outbreak virus as closely as possible to get the best protection. So all things being equal, if you have that the vaccine is matched to the field strain, you're going to get your best protection. Jump to. So, a large part of what I wanted to talk about is how can we predict vaccine protection? And that's still a bit of an issue because, again, as I talk to you, we can measure antibody levels relatively easily using the hemagglutination inhibition assay. Now, the HI assay it's a good measure of protection, but it isn't actually measuring all the neutralizing epitopes that are available to us in a vaccine, but it does probably capture most of that. And it's common to use the vaccine antigens in our HIs to show the best response for the particular vaccine. But as I'll point out, is it's really best to compare the antibody produced by a vaccine and use the challenge antigen for your HI to get a more realistic view of how close of a match it is. Now, when we're asking for predictions, what I can always comfortably say is if we have HI titers of 40 or above to the challenge virus, we're going to see very good, reliable protection in the laboratory and a very large reduction in virus shedding. Now, the problem is HI titers below 40 are common and are inconsistent predictors of protection. So sometimes we'll still see good protection, and other times we won't. And again, titers below 40 are just difficult to use as a measure because of that variability that we see. Now, the live viral vector vaccines typically don't have very good high levels of HI antibody, particularly to the challenge strain, but because of that cellular immunity that we talked about, they generally also can give good protection. So again, they can't necessarily be used as a way to predict whether those vaccines are going to protect or not. Now, probably the easiest way to look and compare viruses is by looking at the hemagglutinin amino acid sequence comparison, and I'll talk about that in the next few slides. Again, going back to the cell-mediated immunity, it's just hard to measure that. It's a very difficult assay to perform. And so, unfortunately, we don't have a very good rapid testing method to show that whether we have a strong cellular immune response or none at all. And therefore, it's difficult to try to factor that into our vaccine protection studies. Now, finally, probably the best measure of protection is to look at challenge studies, measuring virus shedding. I think that's probably the best way to do it, but that's very expensive and it's very difficult to get all the things that are done in the field to try to model that in the laboratory. So that continues to be an issue or a limitation on what we can do there. Again, the amino acid sequence comparison of the hemagglutinin gene. It's, again, very quick. We're getting the sequence much faster than we used to. And ideally, we want homologous vaccination where the vaccine and the challenge strain are 99% plus. That's, again, going to give us the best protection. However, we can see generally good protection when the vaccine is 95% plus compared to the challenge strain. And then we're starting to see in the range between 90 to 95%, that it may or may not be effective, and may probably needs to be combined with other vaccines to really get long-term protective immunity. And in general, I don't recommend viruses with lower than 90% sequence similarity. Can you find a vaccine that has less and you can still show protection in the laboratory? Yes, you probably can. But again, remember that in the laboratory, generally, we're working under the best conditions. And when we move out to the field, typically animals, because of all the other things that they're dealing with, don't respond as well as they do in the laboratory with SPF chickens. And therefore, I don't, again, that's kind of just my general rule of thumb. So looking at the amino acid sequence comparison, I use the Turkey Iowa isolate, which is just I'll say a representative 2344B virus that represents all the viruses we're seeing in North America and South America, and comparing that back to other viruses. So when we look at the original goose guangdong virus, it's about 9% different. So again, that antigenic drift over the 26 years, we're seeing about a 9% difference there. And if we were trying to use that as a vaccine, we wouldn't really recommend it because it's on the low end. There's other vaccines that are also clade goose guangdong lineage viruses that are used in vaccines. And again, they range anywhere between 91% to 98.4% of vaccines that are commercially available. Again, some of those, again, if they're producing very high levels of antibody, may be effective vaccines, or they have the cell-mediated immune component for some of the viral vector vaccines. And so we have to look at those on a case-by-case basis to estimate that, and again, ideally back that up with some lab studies. When we look at some of the other viruses, either just Eurasian viruses, H5 viruses, some of these are low-path AI viruses that are licensed vaccines, but again, we're seeing kind of a sharp drop-off in how close they are matched to the circulating strains that we're dealing with today. And so again, well below 90%, probably not a recommendation that I would like to see. And finally, when we look at the North American strains, again, the goose guangdong lineage was a Eurasian strain originally, and we see quite a big drop off when looking at our North American viruses to the goose guangdong lineage viruses. And so in the examples I have here, the chicken haldago is very similar to the very first vaccines that they used in Mexico for the low-path H5, or for the high-path H5N2 and the low-path H5N2. The most recent, or one of the recent strains, again, a Querétaro 2019 virus has already dropped at less than 20% different. I would not recommend those vaccines at all. And a vaccine that we have used before in the US is a low-path AI seed strain. Again, 15%, that wouldn't be a recommendation either. So again, kind of summing all that up, if we have virus shedding is related to levels of antibody and antigenic relatedness of the vaccine to the challenge strain. Again, the higher HI titers do correlate with lower virus shedding. And the closer the antigenic relatedness also correlates to lowest virus shedding. So we want, again, a high amino acid sequence similarity and as high of an HI cross neutralization as we can. And so these are just an example, and these are made up, so don't try to look at them in a particular study. But if we had an HI titer of 40 with 100% match to the vaccine, then we're going to have very good protection in our challenge studies in the laboratory. If we have an HI titer of 320 with a 94% of match to the vaccine, and the 320 titer would be to the vaccine strain itself, with only a 94% match, we probably still will have a good vaccine protection. But sometimes it can be hard to get that titers up that high in vaccination field burns. But if we have an HI titer of 40, again, with that same 94% match, we're probably not going to see good protection both in the laboratory or in the field.
David?
Yes.
Could you speak quite slowly for the interpreters?
Yes, I can try.
Thank you. I really appreciate it.
Yes, I have burned out a few interpreters over the years. I'm sorry. So again, recombinant live vaccines, we have 4 different types of recombinant live vaccines that we can use. Again, I've already mentioned that typically they don't produce as high of hemoglobin inhibition titers, but they do provide cell-mediated immunity. And oftentimes, if we're going to use a combination approach where we use a live vaccine initially, and then come with a killed vaccine later, that generally will give us the best protection, at least experimentally. They seem to give better protection with longer lasting persistence. So the question that oftentimes is brought up to me is that, you know, we have a vaccine, it's not a very closely matched vaccine. So is that vaccine going to be worse than nothing at all? And my answer is generally yes, for these reasons. Again, a marginal vaccine may reduce or prevent clinical disease signs, but often it's not going to reduce virus shedding to the levels that we would want to have it as a control tool in the field. Again, if a clinically normal bird is shedding large amounts of virus, that will increase the risk of virus transmission. So the potential of moving birds that are infected but not showing clinical disease is higher. And the potential for human exposure is also going to be increased. And so you're losing one of your key signs as an epidemiologic surveillance tool of having sick animals in the field. And I also think that having a poorly matched vaccine actually increases antigenic variation. It forces the virus or provides an incentive for the virus to change even faster because you're allowing more virus replication to occur. So the optimal vaccines, I mean, again, we have a number of different vaccines that we can choose from. Obviously, we'd like to have essentially an autogenous vaccine where we're vaccinating with something very close to what's circulating in the field. We also have to factor in the immunogenicity of these vaccines, particularly with the killed vaccines. If we have good adjuvants, that can really increase the amount of antibody that we produce. And so that does play a major role in these vaccines. And then we have to look at the persistence of the immune response. How long will these vaccine responses last? Will we get good protection over the life of the animal? And oftentimes we are going to have to vaccinate with multiple doses of vaccine. Of course, the cost has been mentioned. It will cost us both to buy the vaccine and to administer the vaccine. So that has to be brought into consideration. And has been mentioned previously, we don't really have good options for mass vaccination for birds once they're placed on the farm. So practical application. Single dose vaccination is unlikely to provide long-term protection, particularly for layers or turkeys or breeder birds. We're going to need multiple doses of vaccination. Historically, when we look at when they vaccinated in Italy, they were having to vaccinate their turkeys 2 or 3 times during the life cycle of the birds to get what they felt was acceptable protection. I had mentioned prime boost vaccination previously. And again, combination of a live viral vector vaccine with a killed boost, I think does provide lots of advantages in the field. So combination vaccines using different antigens may also broaden the immune response, but that's probably going to increase the cost of the vaccine as well. Just a couple of comments about DIVA. I know that a couple of the speakers this morning have talked about DIVA as well. And again, we really want to differentiate vaccinated only and vaccinated and then infected poultry. And as was described, we really need a good companion diagnostic test that's inexpensive, reliable, fast to make this really practical. And again, for poultries that do not export poultry, DIVA vaccination is probably not a major priority. DIVA is really to try to convince your trading partners that the products that you have are safe and that you have a system in place to assure them that if they're trading with you, that the product is free of virus. Now, all the different DIVA strategies out there, these are the 3 in green that I think have some promise. The heterologous neuraminidase DIVA strategy for killed vaccines. And then we have the subunit vaccine approach for that we can use the nuclear protein ELISA test that was described earlier, or even AGIT. certainly don't want to discount that we can continue to use real-time RT-PCR for testing of products, because again, as was mentioned previously, serologic approaches tell us what happened a week or more ago, whereas we probably want to have some testing of the poultry and poultry products to show that they are free of virus. Okay, I think I'll skip over that. I think probably the big concern that I have with the serologic DIVA strategies is that if we have birds that are well vaccinated, it may be an issue of trying to have a high enough level of seroconversion with those birds to allow us to have an effective DIVA strategy, which means that we just may have to test more birds to make a DIVA approach work. And because of that, that will increase the cost. So that has to be considered into that. We do have to validate these approaches to make them effective in the field. So again, conclusions, and this is kind of summarizing a lot of different things. Again, we have homologous vaccination. I don't want to underemphasize that. Matching the vaccine to the field strain, I think, is really the goal that we all want to see. There's many types of vaccines that are commercially available. Some are closely matched to the field strains, some are not. And you have to factor that in to whether you want to use those vaccines in a vaccine control program. Quality vaccine is needed, but also quality administration. If you have if your vaccination crew is not administering the vaccine properly, you're wasting a lot of your time and money and exposing your flocks to disease. Again, I think multiple doses of vaccine are going to be needed. I don't see any way around that, particularly for longer lived birds. Maternal antibody will affect the quality of the vaccination, and so that may affect some of the things that you can do or delay the immune response. And again, it may require an additional vaccine to get the vaccine levels of protection that you'd like to see. DIVA surveillance is possible. I think we can come up with a viable DIVA strategy. But again, we have to convince our trading partners that that they accept that approach. And vaccination, again, should not be used in place of good biosecurity and other control measures. Les Sims, I think, talked about that earlier today. So with that, I will turn it back over to the moderators, and thank you for your time.
Muchas gracias, David. Muchas gracias por el tiempo, por la presentación y compartir con las Américas. En un ratito vamos a tener la sesión de preguntas. Nos gustaría que nos puedas acompañar. Y ahora estamos unos minutitos atrasados con el programa. Por lo tanto, vamos a continuar y le voy a pedir al doctor Etienne Bombón que haga la presentación que tiene relación con comercio de aves y productos avícolas, aves vivas, animales vacunados y no vacunados. Así que Etienne Bombón, por favor, adelante.
Gracias, Luis. Buenas tardes. Lo siento, pero voy a hablar inglés. Un inglés muy francés. I'm sorry, but I think maybe that will be easier maybe for the interpreters. Do you hear me? Do you see the slides?
Sí, se ve.
Yes.
Adelante.
Okay, thank you very much. So after this very scientific explanation, and I'm sure this is really something needed to look at the way to control HPAI and AI in general. But you all know that we have been working a lot in the past years about how also to elaborate and develop and adopt harmonized rules about how we are going to deal with this disease. What is it, the definition of the disease, how we can claim freedom, and how we can trade safely poultry and their products, and how surveillance is to be conducted in order to be able to claim freedom, and also to make surveillance on the flocks that might be exporting animals. So in a few slides, I'll try to show you a generality of what is in the current chapter of the terrestrial code on HPAI. Some key aspects of this chapter, and especially on the scope of the chapter, on the case definition, the status, the trade, and the surveillance, as I just told you. You have seen a presentation by Gunaran this morning that explained in one slide how it is, and I'm going to go a little bit more in the detail. And then we will have a few slides on the vaccination itself, how this vaccination is dealt with in the chapter, and why it has been included in the last version, and how it was included, and what are the consequences of this vaccination, both in the chapter and for the members, and especially for their surveillance, for their status, and the consequences on trade. Because of course, this point of trade was really a key issue that was raised by members, and that said I'm not going to vaccinate because of trade. But maybe we'll see that the trade issues should not be the main driver of the choices of the members in terms of their strategies to combat the disease, and the trade is after maybe the choice of vaccination or not, and a few other points afterwards. So in general, just to tell you that the chapter was updated in 2021, that means less than 2 years ago, but it took 4 years, and I'm very grateful, and the Code Commission is very grateful to the other group, and especially its chair, David Swain, and all the colleagues that worked in this other group, and all the others that in fact gave data to the other groups to be able to finally find a way to adapt the chapters to the epidemiology of the disease, the trade issues, and the trends. Because since the last version, the situation had evolved, and the chapter took into account the evolution of the situation in the world, but it has since again evolved, including recently in Americas, as was shown by our colleagues this morning and beginning of afternoon. So the code is still relevant, because even though the situation has evolved, it had already taken the situation into account. And I think it gives some options to the veterinary authority for them to take decisions, to take measures for the prevention and control of HPAI, including on trade. These measures are not easy, either the control or the surveillance and the vaccination, but still, this is a good basis for the members to begin their work on rules, on internal rules, on prevention and control of HPAI. If the chapter is not up to date, or if some members or some specialists think that the chapter is not answering all the questions, then these data should be brought up by the members to the AMSA, so that the chapter may be updated. However, the first thing I would call on is to apply the code that has been adopted 2 years ago, and then after we will see what are the difficulties on the field for this application. So key aspects of the chapter. The chapter is now only on high pathogenicity avian influenza. However, it doesn't forget some issues about H5 and H7 LPI that can mutate to high pathogenicity. And so these LPI, even though they are not notifiable and they are not in fact in the heart of the scope of the chapter, they are to be monitored and they are to be managed at flock level. So this is important to take into account. These are not notifiable, but they should be looked at, so that we can be ready to react in case of mutation and passage to high pathogenicity. The case definition, in fact, is based on the tests. It's not based on clinical severity, because we have seen that, and you had this sort of explanation in the morning, that sometimes it has no clinical severity in some species, while high clinical severity in others. So the case definition is based on the test that is in the manual, in the manual of the terrestrial animal of the UMSA. Free status is not granted by UMSA. It's a self-declaration. It's based on thorough surveillance. And I will talk a little bit about specific surveillance when the animals are vaccinated. And also on outbreak management, if there are outbreaks, to regain the status. This status cannot be regained easily if there is no thorough outbreak management. That means that, as was said before, vaccination does not allow for loose outbreak management or loose biosecurity. For the trade issues, for the moment, there are only articles for live animals and for fresh meat. There are articles only to trade from free zones or free compartments. So this means that if the country has some free zones or compartments, it can export live animals and fresh meat. If the zones are infected, it can export treated products. This is possible even if there is vaccination, as long as virus circulation is proven not to happen. And so the surveillance, if a country is free and does not vaccinate, is mainly passive, but also there is a need of active surveillance because of the possibility of having cases without a big clinical severity. And even if it's free, the passive and active surveillance are needed. Of course, this surveillance will be different a little bit if there are some vaccination campaigns on the field. So the key points on vaccination, and that's something that these points were newly added to the code. First of all, it is clearly stated that vaccination is an effective complementary control tool when a stamping out policy alone is not sufficient or is not possible, because they say it's not sufficient or it's not bearable or is not economically or allowed or possible in the country. And then vaccination comes as a supplementary control tool, and it can be very effective. The vaccination does not affect the status of a free zone if the surveillance supports the absence of infection. So if there is no virus circulation, eh bien, the status is not affected by vaccination. There is no such thing as vaccinated zone. Okay, in the chapter there is only infected zone or free zone, but vaccinated zone does not exist. Vaccination is just a control tool, and it doesn't affect any status of the zone. And this vaccination is to be decided by the vet authority, and it's based on a lot of things, but mainly on the situation. And we have discussed that in the morning about is the situation risky or not, or is it endemic or not, and do the veterinary services have the capacity to implement vaccination? And just before me, David told about not only the quality of the vaccine, but the quality of the vaccination team is very important, because that would be a big loss to begin vaccination without having the capacity to do it properly. And having this appropriate surveillance strategy to demonstrate not only that the virus is not circulating, but also that the vaccination does protect the animals. That means it's effective. So these tests to be performed to ensure the absence of virus circulation. Again, there is no very prescriptive requirements in the code. The requirements are very general, because it has to be adapted to the risk. And so the code does not give a prescriptive frequency, for example, of testing. The only thing that is said in the code that all the herds where vaccination has been performed, has been conducted, should be included in the active surveillance to determine the absence of circulation. Of course, the use of sentinel poultry, this is still debatable, but in the code, he said they may provide further confidence, and especially when there is no way to distinguish vaccinated animals from infected, from naturally infected. So having these 5 points in mind, the code, I think, takes into account all the possibility and all the need that the veterinary authority should take into account when they decide to go for a vaccination program. And of course, that doesn't give all the tools, but it helps, I think, a lot to see more clearly how to go. Then a few points on trade, because I don't want to take too much of your time, but as I said in the beginning, the trade from free zones and compartment, of course, except safe commodities and treated products, because safe commodities can be traded from anywhere, and treated products also can be traded from anywhere, even from infected zones. So for the moment, there is no possibility, or there is no recommendations. We could not make some recommendations to trade live animals and fresh meat from infected zones. However, this is possible if there are some free compartments. I want to repeat that the vaccination does not affect the status. So if free zone, even with vaccination, the same certificate would apply to that free zone in accordance to the code. So if the country can demonstrate that the zone is free, whatever the vaccination, it is a free zone and can trade. Then not only the surveillance should include all vaccinated herds, but also if you see the certificates for trade of live animals, the herd itself should be free, not only from HPAI, but also from LP, H5 and H7. So that also should be included in the surveillance of the herd that is providing animals for international trade. So that's said, if the animals are vaccinated, then this is to be put in the certificate. That means that not only the certificate says that the herd of origin of the animals or of the parents of the hatching eggs or of the day-old chicks are free, but also info on the vaccines used should be put, the nature and the date of the vaccine should be put on the certificate for trade. And of course, for meat, eggs, and other poultry products, there is no specific conditions related to a vaccination. That is not a question for the products, it's only for live birds. That means for genetic or for hatching eggs. So a few points before I leave, the complementarity with between the chapter on HPAI, what we call the vertical chapter, the 10.4, chapter 10.4, and the horizontal standards of OMSA are very key. I mean, this is important to say that this chapter 10.4 is not the only one to have a look at it. We need to have a look at the chapter 1.4 on surveillance, because general requirements on surveillance apply, and the chapter 4.18 on vaccination. That means no vaccination is possible without planning and surveillance, which is written in the 4.18. The 4.18 also writes that there should be an exit strategy if you want to vaccinate. All these kind of things, and some precision are given about what type of vaccination. Is it systematic vaccination? Is it emergency vaccination? Is it preventive vaccination, etc.? These chapters should be looked at very closely before embarking into a vaccination program. So our other important chapters are chapter 4.4 and 4.5 on zoning and compartmentalization, and especially on the aspect of biosecurity and traceability and movement control. This is not possible to have an efficient and safe vaccination program without having good biosecurity, good traceability, and movement control, meaning that the animals are not moving without being looked at in the country or outside the borders. Last important chapter is the chapter 4.19 on official control programs, because in fact there are ways and recommendations to organize official control programs, including against a disease like HPAI, and this give some good guidance to organize the programs of control within a country, but also maybe within a region, because official control programs could be harmonized between countries of the same region, neighboring countries. And this also gives good guidance to be able to integrate within the control program the vaccination part. Voilà, thank you very much for your attention. I am sorry I cannot stay for the question, but Luis, please don't hesitate to convey to me any questions that would not find an answer, and I will be happy to answer you by writing. Thank you very much.
Gracias, Etienne, muy amable. Las preguntas serán en unos 40 minutos y cualquier pregunta que recibe y no la podamos contestar, te la haremos por correo y luego contestaremos a los países. Muchas gracias. Ahora viene una sesión de las experiencias de los países y tendremos una presentación que se realizará con la experiencia de México, luego Guatemala, Hong Kong, que está grabada, y Ecuador. Tomamos estas experiencias de países que cuando estábamos organizando el seminario eran los primeros que tenían casos. Hoy la situación es diferente, pero piensen que en la reunión de México en abril, que va a ser presencial, vamos a tener oportunidad de conversar y discutir mucho más profundamente todos estos temas. Bueno, por favor le doy la bienvenida al doctor Roberto Navarro de México para su presentación, que va a ser muy breve, como la de todos los de la experiencia de los países. Ya tendremos oportunidad de discutirlo más profundamente en forma presencial, como lo dije en la reunión de México en abril. Adelante, Roberto, por favor.
Gracias, doctor Luis Barcos, y a los organizadores, Andrés González, por haber considerado la participación de México. Bueno, si me apoyan con la presentación, Luis, ¿o quieres que la presente yo?
No, ahí se la ponemos.
Sí, la ponemos nosotros, no se preocupen, eso nos va avisando y ya.
Gracias. Bueno, muy amables. La siguiente, por favor. Bueno, mi participación es como responsable de los programas de vigilancia y de emergencia de enfermedades exóticas, y una de ellas muy importante es la influenza aviar, que se presentó en nuestro país y que hemos tenido algunas otras experiencias con otros virus en el pasado, que ahora tenemos bajo un programa de erradicación. Cuando nos llega esta enfermedad, ¿qué es lo que queríamos hacer? Primero, sabiendo que las diferentes rutas migratorias podían traer el virus H5N1, teníamos que hacer un programa de prevención adecuado. Esta es la cantidad de aves que tenemos en nuestro país, es muy importante, más de 556 millones de aves, más de 1.500 millones de pollos de engorda. Sabíamos que podíamos tener poca vacuna y que lo que debíamos de proteger primeramente eran nuestras aves progenitoras, nuestras aves reproductoras y también las aves de larga vida que se encontraran alrededor de los focos detectados. La siguiente. Para poder hacer una respuesta a una emergencia por influenza aviar, tenemos que tener una preparación muy fuerte, que la tenemos en México, para que podamos también tener un manejo de crisis adecuado, no solamente por la autoridad veterinaria, sino con las diferentes organizaciones de productores y con los gobiernos de cada estado de la República para poderla contener, con la finalidad de mantener la continuidad del negocio de la producción de aves, que también representa seguridad alimentaria para nuestros pueblos. La siguiente. Como les mencionaba, nosotros sabíamos de las rutas migratorias que iban a llegar cargadas de virus, no sabíamos en tal magnitud. Tenemos nosotros buena organización en el país, con centros especializados para el manejo de emergencias, participación con los senadores de la República para buscar recursos y personal de campo para atender notificaciones en tiempos menores a 24 horas, un programa de vigilancia en aves silvestres que lo tenemos desde el año 2014, que ha sido fundamental para este trabajo, y laboratorios de emergencias. Nosotros detectamos el primer caso, H5N1, en octubre del año pasado, y tenemos 156,000 muestras ya analizadas en este operativo. La siguiente, por favor. Esta es nuestra fuerza de trabajo con 88 veterinarios expertos en el reconocimiento de enfermedades exóticas y un programa de vigilancia de más de 18,000 puntos de contacto, la mayor parte de ellos farmacias veterinarias, donde pegamos estos cartelones que se llaman avise para que puedan notificarnos y nosotros atender en menos de 24 horas cualquier notificación, cualquier día del año. La siguiente. Les mencionaba en un principio que el año pasado tuvimos un brote importante de un virus H7N3 que fue controlado y eliminado y que desde el mes de julio no hemos registrado ningún nuevo caso en el país, lo cual es muy importante y es primera vez que lo tenemos. Del lado derecho ven desde octubre 9 la primera detección de H5N1 y el comportamiento que ha tenido a lo largo de las semanas epidemiológicas. Vemos ahí ya 4 semanas sin casos, luego tuvimos un caso de traspatio y ahorita les comento que el día de ayer registramos otro brote en aves de engorda, que son las primeras en el país. Y en la parte de abajo pueden ver cómo nuestro programa de vigilancia es adecuado. Son semanas epidemiológicas de los últimos 2 años, donde ven la cantidad de notificaciones que tenemos de mortalidades y donde hemos podido detectar estos virus de influenza aviar. La siguiente. La siguiente, por favor. En este mapa lo que les estoy mostrando es realmente la invasión que tuvimos de virus de influenza aviar en el país por las 3 rutas migratorias en diferentes estados de la República, los más importantes en el norte de México, donde hace conectancia con Estados Unidos, y la península de Yucatán. Ahí ven cada una de las detecciones, 51 de ellos, casi 6 millones de aves sacrificadas. La siguiente. Bueno, aquí es un ejemplo de los trabajos que realizamos y despoblamiento, las mejoras en las medidas de bioseguridad, el tratamiento de residuos como es las excretas de las aves, limpieza y desinfección. La siguiente, por favor, que se llevan a cabo a través del Dispositivo Nacional de Emergencia de Sanidad Animal. Regresando a la vacunación, nosotros autorizamos una vacuna de emergencia desde el mes de octubre, en el que identificamos que México había 3 vacunas que podían cumplir. Se autorizaron como de emergencia al presentar la documentación. Sin embargo, se hicieron con estas vacunas, se inocularon aves a nivel de laboratorio, se probó que tenían anticuerpos, se desafiaron con el virus que teníamos y 2 de ellas fueron satisfactorias, una de ellas muy satisfactoria, inclusive en la eliminación de virus a nivel de laboratorio, y la empezamos a aplicar de manera estratégica conforme íbamos teniendo disponibilidad de ellas. Inclusive la aplicamos en zonas que nosotros reconocíamos como libres, bajo la estrategia que les acabo de mencionar. No es una vacuna de venta libre, es una vacuna que se entrega a médicos veterinarios que son autorizados por el Servicio Nacional, que tienen que entregar un certificado de vacunación y además tienen que tomar muestras de antes y después de la vacunación para ver el grado de protección. La siguiente. Al momento hemos aplicado poco más de 188 millones de dosis de vacuna en estas regiones avícolas importantes, hablando principalmente de aves progenitoras reproductoras y aves de larga vida productoras de huevo. ¿Qué hemos visto como trascendente? Es que la vacunación de estas aves no es sencilla, es costosa, a veces no llegamos a cubrir más del 50% en lo que estamos observando y requieren por lo menos otra vacunación, que es algo de lo que hay que hablar, las fallas de la vacunación, no porque aparentemente se vacunaron todas, se esté reflejando así en las aves. Entonces son datos importantes. Otra cuestión que estamos investigando es cómo llega el virus desde los humedales donde están las aves migratorias a las granjas, identificando aves puente o aves inantrópicas que son capaces de infectarse en el humedal y llegar a la unidad de producción. Entonces son parte de los trabajos que estamos realizando. Creo que esta es la última. Gracias.
Roberto, muchas gracias por incluso haber sintetizado tu presentación, que tenía muchísima información también, pero tendremos la oportunidad en México de poder profundizar mucho más. Gracias, Roberto, nuevamente, gracias, México. Y ahora sí le doy la palabra al doctor Julio Cordón, para que va a contar la experiencia de Guatemala. Adelante, Julio, por favor. Julio, ¿estás por ahí?
Me parece que se ha desconectado, Luis. No lo veo conectado.
Bueno, vamos a pasar a la presentación de Hong Kong, mientras tanto, y hasta que aparezca Julio, por favor, si está lista, y que se vaya preparando Cristian Zambrano de Ecuador.
Hello everyone, I'm Jeremy Ho from Hong Kong of China. Here I'm going to share some experience about HPAI vaccination in Hong Kong. As background information, we now have 28
Bueno, muchísimas gracias. Vamos a pasar ahora a la presentación de Ecuador, que la va a realizar Cristian Zambrano. Es la última presentación de casos de países. Lamentablemente, por alguna razón, Guatemala se ha desconectado. Adelante, por favor, Cristian.
Hola, muchas gracias, Luis. Una consulta, ¿la presentación nos ayudan desde ustedes, OMSA, o la ponemos nosotros?
Lo hacemos desde aquí.
Gracias, Martín. Bueno, primero agradecer a OMSA, a ti, Luis, por este conversatorio. La verdad creo que es muy importante para los países que estamos atravesando casos de influenza aviar, conocer experiencias, conocer procedimientos, asimismo poder ir analizando la tendencia de lo que las diferentes herramientas o estrategias que como países podemos implementar para el control de esta enfermedad. La siguiente, por favor. Voy a empezar contextualizando un mapa de Ecuador en donde se nos han presentado los brotes de influenza aviar. Este mapa está actualizado a la fecha en la que OMSA nos ha pedido la presentación. A la fecha tenemos una provincia más de las que están ahí en el mapa, que es Imbabura, pero básicamente los brotes en granjas comerciales se nos ha presentado en las provincias de Cotopaxi, Tungurahua y Pichincha, Bolívar e Imbabura con animales de traspatio. ¿Sí? Ustedes pueden ver, de acuerdo a la colorimetría del mapa, que coincidencialmente los brotes en Ecuador en granjas industriales o comerciales se nos presentan en provincias que tienen una alta producción avícola en el Ecuador. ¿Sí? De hecho, en la provincia de Cotopaxi y Tungurahua se tiene estimado que está aproximadamente el 70 a 80% de la producción nacional de huevos en el país. La siguiente, por favor. Dentro de la contextualización de Ecuador, nosotros tenemos aproximadamente 264 millones de aves, de las cuales 14 millones son ponedoras, 2 millones reproductoras. Tenemos una producción de 4.600 millones de huevos al año, con un consumo per cápita de 24 kilos de carne por persona al año y 212 huevos por persona al año. A la fecha y al corte de la presentación teníamos 14 brotes, 7 en Cotopaxi, 2 en Bolívar, 1 en Pichincha y 4 en Tungurahua. A la actualidad tenemos 17 brotes, ¿sí? Se nos incorporó un brote en Cotopaxi, un brote en la provincia de Azuay y otro brote en otra provincia que se llama Imbabura, ¿sí? Actualmente, las aves que han sido afectadas, que hemos tenido que sacrificar y que han muerto por el virus, asciende a 1.2 millones de aves, ¿sí? Si hacemos una relación con los 14 millones de aves de ponedoras que tenemos en el Ecuador, actualmente tenemos un impacto aproximadamente ya casi del 10% de nuestra población de productoras de huevos, ¿sí? Y por ende 1.1 millones de huevos menos diarios en el Ecuador. Como les mencionaba, la producción de pollo en nuestro país de huevos se presenta o está en Manabí, Pichincha, Santo Domingo, Guayas, y la de huevo, perdón, en Cotopaxi, Tungurahua, Pichincha y Santo Domingo. La siguiente, por favor. Como consecuencias del impacto de influenza aviar en Ecuador, el sector avícola aporta al 4% del Producto Interno Bruto Nacional y el 23% del Producto Interno Bruto Agropecuario. Comprendemos que la pérdida de empleos directos e indirectos y de los pequeños productores son los más sensibles y podría llegar a desaparecer. Actualmente ya estamos sintiendo una leve escasez de proteína aviar, en este caso huevos, y un incremento en el precio. Creo que uno de los factores adicionales es que más allá del 1.2 millones de aves que han sido afectadas por el virus de influenza aviar. Tenemos muchas granjas que por precaución o miedo han dejado de producir, o que las que tienen que repoblarse para continuar sus ciclos de producción no lo están haciendo en los números que deberían hacerlo para mantener la seguridad alimentaria del Ecuador. ¿Sí? Un incremento en el impacto de la enfermedad agravaría mucho el consumo en nuestra población y por ende una reducción de la producción avícola. La siguiente, por favor. Aquí un distributivo de cómo se presentaron o se han presentado los brotes de influenza aviar en Ecuador, recalcando que tenemos actualmente 3 brotes más, pero podemos ver que el mes de enero para nosotros fue muy duro como autoridad sanitaria y como país, ¿sí? En donde se presentaron 8 brotes y de hecho en las granjas comerciales más grandes lamentablemente tuvimos que despoblar y atender en el Ecuador. La siguiente, por favor. En número de aves igual, ¿sí? El mes de enero para nosotros tuvo la mayor afectación de aves de postura. Los brotes en Ecuador solo se han presentado actualmente en ponedoras, teniendo casi 806,000 aves que nos tocó eliminar o dar disposición final ante los brotes de influenza aviar que se nos han presentado. La siguiente, por favor. Todo este contexto que yo les acabo de presentar hizo que dentro de las estrategias que como agrocalidad, como autoridad sanitaria de Ecuador, en conjunto con el sector privado, siempre estemos vigilantes de las alternativas a implementar en Ecuador, ¿sí? Creo que tuvimos charlas muy importantes organizadas por la comunidad andina, que ya empezábamos a hablar de vacunación. Agradecemos también aquí a Senacica. Roberto, nos reunimos con ustedes y creo que pudimos también obtener mucha de esa experiencia que ustedes han implementado. El doctor Pastor de Cuba, que también es representante de OMSA, estuvo acá en Ecuador asesorándonos. En Ecuador tenemos una Comisión Nacional de Avicultura que está representada por los gremios avícolas, por la academia y por médicos veterinarios especialistas en la avicultura. Es en este espacio de análisis y este órgano asesor que tenemos como autoridad sanitaria, dentro de los varios temas que involucra tratar para contener la enfermedad, se analizó los pro y los contra que involucra establecer un plan de vacunación contra influenza aviar. ¿Sí? De hecho, con los técnicos, porque en esta Comisión Nacional de Avicultura hay técnicos especialistas en agricultura que son representados por cada uno de estos organismos, y la primera decisión que tomamos fue recomendar el uso de la vacunación, ¿sí? El siguiente reto era, bueno, ¿qué vacunas tenemos en el mercado? ¿Qué vacunas tenemos disponibles? Y ahí hicimos este análisis sobre las ofertas que nos llegaron. La normativa legal nos lo permitía hacer, nuestra Ley Orgánica de Sanidad Agropecuaria, la declaratoria de emergencia que hizo el señor Ministro de Agricultura en Ecuador y las resoluciones internas de agrocalidad. La siguiente, por favor. ¿Sí? La estrategia de vacunación en Ecuador. Utilizar vacunas en foco y perifoco o en aquellas zonas de riesgo que la autoridad así lo determine. Hicimos el análisis de las vacunas existentes en el mercado y autorizamos la importación. En esta Comisión Nacional de Avicultura establecimos los procedimientos para iniciar la vacunación. De hecho, hoy estamos vacunando las primeras granjas en Ecuador, pero con requisitos mínimos a cumplir por parte de los propietarios, ¿sí? Que es primero tener elevadas medidas de bioseguridad, contar con un médico veterinario responsable de la granja, análisis previo negativos a la enfermedad para poder autorizar la vacunación y tener un registro ante la agencia. Los retos que como Ecuador se nos presentan post vacunación, y creo que aquí las charlas han sido muy expeditas en en estos temas es esa vigilancia que tenemos que hacer, ese control de la movilización y sobre todo que el sector entienda que la vacuna no es la solución, sino es una herramienta más que nos permita controlar la enfermedad. Me parece que esta era nuestra última diapositiva y por parte de Agrocalidad y de Ecuador le volvemos con nuestro agradecimiento a Luis, a OMSA y a todos quienes han estado exponiendo en este día. Muy amable, gracias.
Muchas gracias, Cristian. Muy amable por tu presentación y compartir la información de tu país con el resto de los países de América y otros países que hay presentes. Le voy a pedir a Julio Cordón de Guatemala, que ahora se pudo conectar, que pueda realizar su presentación. Julio, por favor, adelante. Estamos un poquito atrasados a último tiempo, pero creo que vale la pena el esfuerzo. Julio, ¿estás por ahí? Julio, ¿me escucha?
Sí, buenas tardes, ¿me escuchan?
Sí, sí, adelante, Julio.
Perdón, con las disculpas correspondientes, pero tuve problemas técnicos. Muchas gracias por esta oportunidad y ya estamos listos. Bueno, vamos a compartir la experiencia que tenemos en Guatemala sobre los programas de vacunación contra influenza aviar H5N1 y H7N3. La siguiente, por favor. Bueno, antes que nada, quiero compartir con ustedes que la avicultura guatemalteca son 83 millones de aves, pero de esta avicultura, el 32% es avicultura de traspatio. Es decir, que tenemos un 68% de lo que es la avicultura tecnificada, y de esa avicultura tecnificada, pues tenemos lo que son aves de engorde, aves de postura y reproductoras. La siguiente, por favor. Bueno, para los que no conocen dónde está ubicado Guatemala, pues somos frontera con México, Honduras, El Salvador y Belice. Es también importante mencionar que esta avicultura guatemalteca, como les decía, que estaba constituida con 83 millones, tenemos 56 millones de aves. Y para los programas de vigilancia epidemiológica, necesitamos saber dónde están ubicadas estas unidades de producción avícola. De tal manera que en el centro de Guatemala prácticamente tenemos ubicado el 84% de la avicultura nacional. Eso es información de acuerdo a la vigilancia epidemiológica que se realiza en el país y a la evaluación de las medidas de bioseguridad. La siguiente, por favor. Bueno, sin embargo, esta avicultura guatemalteca se ha visto amenazada por el virus de influenza aviar. En 1995 con el virus de influenza aviar de alta patogenicidad H5N2 en México. Luego en el 2012, H7N3, también con un repunte de la República de México. Y en el 2022, pues tenemos el repunte que ya todos conocemos de H5N1 y que fue ampliamente discutido hoy por la mañana. Esto representa una amenaza para la seguridad alimentaria y nos ha obligado a fortalecer aún más los controles sanitarios que el país tiene establecidos. La siguiente, por favor. Y a esto nos referimos, estamos completamente de acuerdo a lo que escuchamos hoy por la mañana, de que no debemos de pensar que solo con un programa de vacunación nosotros vamos a lograr controlar la enfermedad. En el caso nuestro, estamos apegados a las normas internacionales, en este caso de la OMSA, y como también estamos apegados a normas nacionales. Todo nuestro quehacer dentro de la sanidad avícola nacional se rige por normas que establecidas y son de observancia en todo el territorio nacional y de cumplimiento. De tal manera que realizamos actividades de vigilancia epidemiológica pasiva, hacemos actividades de vigilancia epidemiológica activa. Tenemos también en lo que se refiere a la evaluación de las medidas de bioseguridad en todo el territorio nacional, en todas las unidades de producción avícola. Y en este caso, como vamos a hablar sobre los programas de vacunación, pues tenemos un programa de vacunación preventivo contra influenza aviar H5N2 y tenemos un programa de vacunación preventivo contra influenza aviar H7N3. Y estamos por iniciar un programa también preventivo contra influenza aviar H5N1. Todas estas acciones también verificamos el control en el movimiento de animales de aves y productos avícolas en el territorio nacional. Y también este tipo de actividades se ven fortalecidas con una capacitación a nivel de todos los sectores, tanto en el sector público como en el sector privado. Y lo que buscamos es la atención temprana y la respuesta inmediata, como sucedió en el caso que recientemente reportamos a la ONSA del caso de Motagüilla en Puerto Barrios y Zabal. La siguiente, por favor. Para fortalecer esta capacidad de diagnóstico a nivel nacional y los programas de vacunación, la sanidad avícola que lleva a cabo Guatemala tiene establecidos laboratorios oficiales y laboratorios oficializados. Los primeros dos que vemos en esta imagen son los laboratorios oficiales y luego tenemos los laboratorios oficializados. Y para el caso de influenza aviar, tenemos establecidas las pruebas de inmunodifusión en agar gel, la prueba de inhibición de la hemoaglutinación, la prueba de PCR, aislamiento viral, el índice de patogenicidad intravenoso, y estamos por establecer lo que se refiere a la secuenciación viral. Con ello, nosotros esperamos poder tener esa capacidad de diagnóstico de una manera rápida y estaríamos confirmando nuestros resultados con el laboratorio de Insagua, que fue el que, como trabajamos recientemente. La siguiente. Bueno, con esta actividad lo voy a pasar rápidamente. Se han identificado, hemos aislado virus de influenza aviar. Básicamente vemos que todos han sido virus de baja patogenicidad y prácticamente los hemos identificado y detectado a lo largo de la frontera con México. Y las cepas virales que hemos encontrado, pues están emparentados con las cepas que están circulando en México. En el caso del virus de alta patogenicidad H5N1 que identificamos en el Atlántico guatemalteco, pues es una cepa viral de las que está circulando en los Estados Unidos, y en Centroamérica y en América del Sur. La siguiente, por favor. Bueno, para llevar a cabo nuestros programas de vacunación, nosotros estamos utilizando en las vacunas de influenza aviar H5N2, pues una cepa mexicana que es la 23294, y esto lo hemos hecho, o sea, la decisión fue tomada en base a algunos análisis e investigaciones que nos permitieron definir el programa de vacunación a seguir. La siguiente. Para ello, bueno, venimos trabajando desde los años 2000. Hicimos una inspección a los laboratorios de producción de biológicos de México. Habilitamos los laboratorios de los cuales está autorizada la importación de dichos biológicos y estamos aplicando en el país lo que son vacunas monovalentes, vacunas bivalentes y vacunas recombinantes. Básicamente todos son de la cepa 232, 94, en este caso que es una cepa pues mexicana. La siguiente, por favor. Todos los programas de vacunación están apegados a las medidas sanitarias, como les expliqué, como un resumen desde el inicio de la importación. Primero la inspección del laboratorio, la importación, la autorización de la importación, la distribución de los biológicos. El médico veterinario oficial o oficializado debe de reportar la aplicación del mismo, y todas aquellas unidades de producción avícola donde nosotros estamos aplicando los biológicos aviares contra influenza aviar de los 3 subtipos que mencioné, necesitamos dejar obligadamente 50 aves centinelas, las cuales van a ser objeto de monitoreo. Y básicamente también se lleva un control apegados a normas nacionales e internacionales en lo que se refiere a las áreas libres con vacunación, granjas libres con vacunación, como también llevamos un control a lo que se refiere de las granjas libres sin vacuna. La siguiente, por favor. Con todas estas medidas y todas estas acciones que se han tomado, podemos garantizar y demostrarle al mundo y a nuestros socios comerciales que Guatemala es un país libre de influenza aviar de alta patogenicidad, y esta condición nosotros la notificamos a la OIE en su oportunidad en enero del 2004, y es una condición que mantenemos hasta la fecha. La siguiente, por favor. Bueno, como proyecciones y ante la amenaza que tenemos y el riesgo sanitario que representa, tenemos fortalecer las medidas de bioseguridad en todas las unidades de producción avícola. En Guatemala, para poder comercializar aves o productos avícolas, deben de estar registrados en el Programa Nacional de Sanidad Avícola. De lo contrario, son objeto, cuando circula el producto, son objeto de detención, y las personas en un momento dado, pues, van a la cárcel, pues, y tienen que llegar a un proceso judicial. Por otro lado, vamos a seguir estableciendo y fortaleciendo nuestros controles a nivel de puertos, aeropuertos y fronteras. Y lo que buscamos con esto es minimizar el ingreso del virus de influenza aviar al territorio nacional, como también vamos a fortalecer nuestros controles a nivel interno en lo que nosotros le llamamos puestos de control institucional. En estos puestos de control institucional, que funcionan 10 estratégicamente ubicados en el territorio nacional, y estamos trabajando coordinadamente con lo que es el Ministerio de Gobernación, la Policía Nacional Civil, el Ejército de Guatemala y la Superintendencia de Administración Tributaria, que es la SAT. Y bueno, continuaremos con nuestros aislamientos, continuaremos con lo que es la secuenciación viral, el índice de patogenicidad y el índice de patogenicidad intravenoso. La siguiente, por favor. Bueno, muchas gracias, y con las disculpas correspondientes, y estamos ahí a la orden.
Gracias, doctor Julio Cordón. Muchas gracias. Bueno, nos hemos excedido un poquito en el tiempo, y viene ahora la sesión de preguntas en plenario. Las preguntas, el plenario va a estar facilitado por el doctor David Swain y mi persona. Están presentes varios de los oradores. también el doctor Les Sims de Australia, que es muy temprano. Gracias, Les, por levantarte tan temprano y participar en la reunión. Y el doctor David Swain decidirá si responde a la pregunta o la deriva a alguno de los oradores. Las preguntas se van a recibir únicamente por el chat, así que los invito a formularla por el chat. Las preguntas van a ser traducidas al inglés. Les pido que sean concretas y cortas, porque vamos a ir traduciéndolas. El doctor Martín Minassian va a traducir las preguntas. Así que podemos comenzar con las preguntas. Ya tenemos una de Cuba, otra de Belice. Hay otra pregunta, Martín, que te había enviado de una persona de Procisur. No sé si la tenés ahí para ponerla en el chat. David, ¿está listo para...?
Yes, we'll start with a question from Belize. It's in English. Says, any recommendations for vaccination of captive wild birds in zoos and aviaries? And I'll deflect that question maybe to Dr. David Suarez, who has been dealing with this question in the United States.
David Suarez?
Yes, no, I'm sorry. I got distracted. So is this the question? Okay, on the zoos and so we are looking at zoo vaccination in the U.S. I think it's at the APHIS level. They're looking at that. I think the big concerns are, will that have any effect on trade, even though it's not a poultry species? I think there is some concerns about how that might affect trade. And in the U.S., again, looking at the commercial vaccines that we have available, we have the killed reverse genetics vaccine that, you know, sequence-wise is pretty close. And then we also have the RNA particle vaccine that is also could be a possibility, is inactivated agent. So we are not considering using the viral vectored vaccines because the HVT vectored vaccine in particular will not work on the different species. It is more of an adapted strain to chickens and turkeys.
I'll just make one addition to that. Back in the mid-2000s, this is 2005, 6, and 7, in Europe, there was a project to look at vaccination of zoo birds. This was against H7, and actually they used kill vaccines that were commercially available. These were poultry vaccines, and they did have very good success in their project in producing hemoglobin antibodies in a wide variety of bird species. I think it was generally successful. So it should be today the same sort of success if vaccines are used. These are the kill vaccines that have close antigenic match to the field viruses. They should be effective in a variety of zoological birds. I think the only caveat I know of that was a potential contraindication is some high-valued citizen birds that were given oil emulsified vaccines. Some of those birds did quit laying, and I'm not sure if that was a permanent stoppage in laying of eggs. And I think that might have been studies that were seen in Hong Kong. So if Les Sims, if you would want to make a comment on it.
Thanks, David. Nothing specific on that particular issue, but there is vaccination of wild birds, captive wild birds occurring at the moment in Europe. There's a number of countries still doing that. Not all birds respond appropriately to these vaccines, but the vast majority will produce an antibody response to it. And I think it is a worthwhile thing to consider. Over.
Hey, Dr. Marcos, do you want to read some of the Spanish questions?
Yes, David, you could see in the screen the next question in English at the right side, and the Spanish, the same question. Okay. Yeah, Ariel Pereira, and then you have another question down. We will
all right.
Scroll the question. Yes.
Thank you. So this is from Ariel Pereira in Argentina. Is there any information about the level of immunity that the HA of the 2344B has or also would be asked as? What is this level of immunity? Not all H5 are immunogenic, so that's a good question. And I'm going to deflect that question maybe to see if Erica Spackman and then maybe David Suarez would have any comment.
Yeah, I can try to answer that. We have, because we make a lot of serum and do a lot of vaccine testing here, compared to other H5s, including 2344s that we've made serum to, and granted this is using adjuvant, but comparing using the same adjuvant, this is reasonably immunogenic. It's not one of the best for generating antibodies, but it's definitely a little bit above average, I would say. It's hard to put a quantity on it, but it is reasonably good from what we have observed.
Any follow-up, David?
No, I think Erica probably has the most up-to-date information. Again, the 2344C vaccine gave us a good immune response. I don't have direct experience with the 2344B personally, so Erica probably has the most update.
Okay, thank you. We'll go on to the next question. For the scenario of non-endemic countries applying emergency vaccination, what have been or could be the most successful practices in case of detection of high-path AI viruses in vaccinated poultry, and what experience is there of safe handling of poultry products from high-path AI positive farms? And I'm going to deflect this one to, let's see, I think probably Les, that's probably the best for you to answer.
Thanks, David. We don't have huge experiences with emergency vaccination, so we don't have a lot of cases where this has been applied for HPAI. Most of the vaccine's been applied in endemic countries. If you're using emergency vaccination and your goal is to eliminate the virus, if you are finding circulation, as in persistent circulation of a virus in a vaccinated flock, and your goal is elimination, then the most rational approach would be to cull that flock. But if you're in a situation where you expect the virus is becoming endemic, then your goal is suppression, and you have to make the call on a case-by-case basis.
You maybe just expound a little bit, because I think Jeremy Ho, in his presentation, he talked about the 20-year experience in Hong Kong, and you were intimately involved in that. And he did make, I think, the comment that it was very uncommon to find the virus in vaccinated flocks, and that was in the presence of pretty heavy surveillance, both dead bird mortality as well as sentinels. Could you kind of elaborate on that?
Sure, David. Absolutely. I mean, one of the things that we know that we don't always get sterilizing immunity when we're dealing with avian influenza, but if you look at transmission studies, you often don't get transmission, even though some birds may well be shedding virus. So we've got to be careful how we interpret this. There were cases from Hong Kong in 2002 and 2003 where vaccination was used in the face of outbreaks, and the outbreaks were ceased after vaccination was used. And these have been published. The work from Trevor Ellis on an outbreak in 2003 showed that you could stop the virus from circulating within about 18 days of vaccination. They did use some culling. So when they saw birds being infected, they culled those birds, but over time, there was no evidence of the virus being found. There are also the experience with low-path viruses in the USA that David Helverson has published, and you're familiar with that work, David.
Right, yeah. Similar experience in vaccination in the face of an outbreak, and our most recent one was in Connecticut in 2003 through 2005 in a large layer farm. In that case, vaccine and that was applied to the outbreak farms. These were layers that were already in bray with a single dose, and then those were slowly rotated out on a monthly basis, replaced by double vaccinated pullets. And in actuality, that with the surveillance, they were doing both sentinels as well as dead mortality surveillance. I think after about the first month of the vaccination program, there was no more detection of virus in either sentinels or in the dead mortality. So it was effective in the face of a low path H7 break. One last follow-up on, it's a nice long question. It's a very good question, but the other thing was mentioning about what's the experience in safe handling of poultry products, and specifically eggs from HPAI positive farms. And I assume this is vaccinated positive farms. Any comment on that?
The only comment sorry, David, there have been some studies have shown that that you can get virus on the surface of eggs or in the content of eggs in unvaccinated birds challenged with the virus. But the likelihood of that happening with a vaccinated flock is going to be very, very low. So again, if you're using a good vaccine, you're getting good response to the vaccination, you should not have an issue with that. By monitoring your flock, you'll be able to tell whether or not you have virus circulating. And I think that's the most important way of going down this road. We haven't yet explored other options, such as doing egg washes as a possibility, but these are things to consider for the future. Over.
Yeah, I can confirm the experimental studies that we did at Southeast Poultry looking at vaccinated birds that, at least the studies I did 10 years ago, we couldn't recover virus from the internal content of eggs from vaccinated hens that had been challenged. One last part of that question, and we'll go on to the next one. Can a reasonable time frame be estimated for, oops, I'm sorry, go back down. I was trying to read the last part of that question. Just a little bit more. There, okay. Can a reasonable time frame be estimated for lifting emergency vaccination once it is introduced, and what surveillance results should underpin this decision? I think that probably go back to Les again.
It all comes down to this whole cycle of vaccination. So if you're using emergency vaccination, then you're probably aiming to stop vaccination if it's a one-off challenge that you're working on. And so if you're monitoring all your vaccinated flocks and you're finding there is no virus in those vaccinated birds, if you manage to stop the outbreaks, then you could consider stopping vaccination. But in your current situation, where you have this virus present in wild birds, you have an ongoing threat. And so that you then have to make the call, do I continue to vaccinate on a preventive basis when we have that situation? Over.
Thank you. We're going to move on to the next question from Argentina. In the morning session, the speakers talk about pros and cons of vaccines and vaccination, mostly pros. The vaccines are valuable tools for improving resistance to HPAI, no doubt about that. However, in some South American countries, this is the first report of HPAI in commercial birds, and the reported cases are still few, so it seems to be too early to start vaccination at this point. An additional to start a vaccination program comes along with a lot of issues, a lot of evaluations of proper and continuous vaccination, continuous surveillance to check if the vaccine matches the field strain. So, in your opinion, what is convenient to take the decision? When is convenient to take the decision of starting a vaccination program? What should be taken into consideration before and to initiate vaccination? Is it any epidemiologic variable that should be evaluated? So that's a lot of questions. Let me kind of give Les a break, and I'll deflect this question, starting off with maybe Erica and then David Suarez, because part of that question is about the decision of how to match vaccines with a field strain, and the question, or it could even be deflected to Mia on, are the viruses that have been analyzed very different, and maybe a comment about that.
So I guess I'll take a quick stab at it, and I think it really depends so much on the situation and what the cost benefit is for the country or the production sector. There are a lot of variables about the value of the birds and how it can affect markets and the actual cost of vaccination, of course, and how available the vaccine is, if there's an adequate supply for the populations you need to vaccinate, and vaccines of the type that you need. So especially looking at whether you want to do breeders, broilers, or layers. Once again, that has to do with the cost and the lifespan, the value of the birds. So broilers are probably less likely to be vaccinated in a lot of areas, but that's a decision that probably needs to be made by the individual country and the production sector. I think there also has to be an infrastructure in place for the monitoring and the surveillance that's been talked about as well. But that's another consideration to make sure that component is available. Over.
And maybe David and Mia, I guess, since we're talking about huge geographic areas this virus has spread to, and we're having outbreaks now starting in South and Central America, do we know that we have vaccines that will match the field strain? I think David made some comments about it, and then maybe Mia can follow up on it.
Right. So, I mean, when we look at the viruses that, you know, we have sequenced for, the hemagglutinin, again, has not been changing that much. So I think it's more, is there vaccine available in the country that you're interested in vaccinating? Because just because there might be a vaccine available in one country doesn't mean it's going to be available in another country. And so, you know, each country, unless they have some emergency regulation to allow the import of vaccine, may have fewer options available to them. And because the virus has spread so quickly, I do think we're going to have issues of not enough vaccine available for the countries that want to start vaccination. But as Erica appropriately described, you know, I think there is probably going to have to be some prioritization about what sectors that you want to vaccinate in, with the higher value birds probably being the priority, breeders or layers. Turkeys for those companies that have that. Fortunately, the broilers, you know, in the U.S., it's been a relatively small number of flocks that have been infected in the U.S. has been broilers, probably because of less people moving on and off the farm. I think that's probably the largest epidemiologic factor. So again, it is very dependent on the country, and of course, if it's a country that trades, they're going to be much more reluctant to vaccinate than countries that are just producing for their local markets. Over.
Okay, so I think maybe the last part of that question, if Les wants to take a stab at it, is, you know, when would you make the decision to do the vaccination? And I think Les talked about that in his presentation. I did a little bit about whether you're talking about a preventative vaccination program, or you're talking about an emergency vaccination program, or a routine vaccination program. In the case of Central and South America, each country has to make that decision for themselves. And it may be that because we know of experiences in Europe and then Canada and the US, that this virus is established in wild birds, it's most likely going to be around a long time. And that means it's going to be continual threats of reintroduction from wild birds into commercial poultry. So Les, do you want to make any specific comments on that?
Thanks, David. Just again, referring back to my vaccination cycle in the first quadrant of that cycle, are you able to control this virus using your traditional methods, your standard methods? And or is that going to be sustainable? So if you're having to cull millions of birds to control the virus, do you then start looking at, are there other ways of adding to that, perhaps by using vaccination? So the first question is, are we winning at the moment using the methods we are using? If not, then you should consider vaccination. And then you have to then go through all the aspects about vaccination. Do you have the appropriate amount of vaccine? Do you have the right vaccine? All of those issues need to be sorted out. But yeah, for some of your countries, one of the issues is you won't be able to find all of the cases quickly enough. So you may not be detecting the virus. You may not be able to keep up with the outbreaks. In those situations, when you start moving towards more endemic infection, then I think you should be considering, seriously considering implementation of vaccination. If you have small numbers of outbreaks, which you can handle by stamping out, then that is the logical approach initially. But you again, you just have to weigh up the pros and cons of how far you have to go. As Erica said, this becomes an economic decision, but also there's some welfare aspects of that as well. Over.
hand up, maybe wants to make a comment.
David, may I add something to that? That question from Germany.
Yes, please.
Because I think that's a very important question about the category. Because I think that the experience in Europe, yes, certain species and certain categories are suffering more, as it was mentioned. Broilers are apparently, well, at least in the industrialized world, not as or the danger is not as high, whereas for Germany, apparently the turkeys, they were really in danger, or when you really keep animals outside like geese or ducks. So I think in this consideration, it makes perfectly sense that you consider not do a blanket vaccination of the area, but rather look what type of species is in danger of that. And in particular for broilers, I like to point out, yes, if you do a vaccination of the population, if you do vaccinate breeders, please consider that maternal-derived antibodies are inhibiting early vaccination. It was always said that you then can start only vaccination before. And this should be something that has to be considered all the time. So don't make the mistake to vaccinate too early.
Thanks, Christian. So we'll move on to the next question. This is from Fanavi in Colombia.
David.
Yes.
Well, we have now 10 more questions in the list, and we don't have enough time for answer all the questions. I propose, because Dr. Shakshir need to leave the meeting, and I let him the opportunity to Shaq and Andres Gonzalez close the meeting. And if you agree, we take a note to all the questions and send to all of you, and we will send the answer to all the participants by email. But we don't have, unfortunately, the issue are really, really high interest, but we don't have more time.
Okay, so do we proceed with a few more questions, or do we need to go ahead and let Jack
One
close?
more question if you like,
Okay.
and then we close the meeting.
Okay, let's take the first part of the question that Diane from Fanavi in Colombia has, and this is regarding experience of the use of vaccine in countries that intervene. Do they all carry out the sanitary slaughter of positive batches? So I think this she's stating is that if you do vaccination and then you have a positive case, positive for HPAI, what is the outcome of that case? And I think we'll have maybe Les start off with that answer, and if other speakers want us to give an opinion, that'd be great.
Thanks, David. I can use perhaps Vietnam as an example, where they've been vaccinating for a long time, since 2005, against avian influenza. If they have an outbreak where birds are affected and dying, a clinical outbreak, then that flock will be destroyed. But if you're in a country where your goal is elimination, then any positive case would be treated the same way as an unvaccinated flock and would be destroyed. That's the sort of the general sense. So it depends on whether you're using suppressive vaccination, and that happens when you can't, when you're not going to be able to find all your cases, where you can't do surveillance on all your farms. But generally speaking, if you're finding evidence of transmission and disease in a flock, that's usually an indication that you either haven't vaccinated it properly or you're using the wrong vaccine. And in which case, if that's the case, then you should be destroying that.
Speakers in comment?
I might add, this is totally true for Europe. This is Christian from Germany. For Europe, yes, if you would detect an infected, vaccinated flock, it has to be eliminated.
I think we have several more questions in the queue. Nestor also from Colombia, kind of had the same question, and I think between Christian and the Sims, that was answered of, if you do have detection of positives, and yes, those are put down. It's the same way in the United States, that if we vaccinated, and detected the virus, then we would put that flag. Okay, Dr. Barcos, I think we will stop there and
yeah.
Turn it over to you.
Yeah, it was really interesting, a lot of interest, a question, and but we will send the question to all the speakers and back to the all the participants with the answer. I give the floor for the close of the meeting to Dr. Jacques Scheer and Dr. Andrés González Serrano. I think first Dr. Andrés González Serrano and Jacques Scheer, as president of the Scheer Stad, will give the final statement. Andrés, please, and then Dr. Scheer.
Bueno, muchísimas gracias, doctor Barcos. En nombre del GFTAD de las Américas y de la co-dirección de este grupo regional coordinado por FAO y por OMSA, agradecemos a los conferencistas y a los participantes de la región y de otras partes del mundo por acompañarnos en esta tan importante discusión. Y también mencionar el importante rol participativo del sector privado y del sector público, de los delegados de la OMSA y de las respectivas organizaciones regionales en esta reunión. Como bien se ha comentado durante la reunión, es de alta preocupación la situación de la influenza aviar altamente patógena. Está ocurriendo en este momento. Hay que mencionar que la situación sigue evolucionando y aún no sabemos cómo va a terminar. Se encuentra en pleno avance dinámico. Lo que sí sabemos y tenemos completamente claro es que la enfermedad no es bienvenida en la región y que ya ha empezado a generar enormes impactos económicos y sociales en la región. A pesar de la situación que se está viviendo actualmente, mantenemos firme el objetivo de erradicarla de las poblaciones de aves domésticas, de no permitir que se establezca como endémica en los países de la región, y estamos conscientes de que es una situación compleja y un tremendo desafío la que atraviesan los países de las Américas. Hay que mencionar también que queda mucho por conocer sobre la situación epidemiológica en cada uno de los países, en las poblaciones de aves silvestres y aves domésticas, y lo que está pasando con la aparición en algunas especies de mamíferos también. La situación es muy diferente y varía de país a país, y por ello se evalúan las reales capacidades de los países para enfrentar la enfermedad bajo diferentes escenarios. Estos son pasos fundamentales, como lo han comentado la mayoría de los conferencistas, para la decisión de vacunar o no, y en caso de hacerse, que se haga siguiendo un estricto plan de vacunación. Recordar también que hay que tener en cuenta que los países de la región tienen una combinación de sistemas productivos con diferentes especies, diferentes sistemas de exportación, tanto de carne como de huevos, granjas de diferentes tamaños, enormes cantidades de producción de traspatios formales e informales, así como una gran diversidad y distribución de aves silvestres. A pesar de estar estipulado y descrito en el código de la OMSA, de los avances científicos y de algunos ejemplos exitosos, hay que reconocer la cantidad de dudas que aún persiste en torno a la vacunación como medida. Y por ello es valioso poder entregar información a través de este tipo de eventos y de reencuentros. Se deberá favorecer la discusión con énfasis en los temas más complejos, como la selección de la vacuna, el impacto en el comercio y en las dificultades prácticas de su implementación, especialmente en la aplicación de la vacuna y en la vigilancia. Lo importante es que cada país deberá hacer su evaluación costo-beneficio de corto y mediano plazo para tomar decisiones basadas en la evidencia, y esto con la mejor información posible. Finalmente, quisiéramos enfatizar que estamos en medio de la emergencia en la región y revalorizar y remarcar, como también se ha dicho mediante las charlas de todo el día de hoy, tanto en la mañana como en la tarde, las medidas clásicas y fundamentales con o sin vacunación, como lo son la detección precoz, el sacrificio de las aves de los focos identificados, el control de movimiento y la bioseguridad. Por último, Mayores detalles y recomendaciones concretas con enfoque regional y nacional serán definidos en la próxima reunión del Grupo Permanente de Expertos en Influenza Aviar a celebrarse el próximo mes de abril en la Ciudad de México. Muchísimas gracias y nos vemos en la Ciudad de México. Adelante, doctor Chile.
Chuck?
Luis, I'd just like to keep it pretty simple. I'd like to thank you for setting up this conference and all of the information that the speakers brought to us. Thank you to the speakers. It was excellent information and evolving information. A lot of ideas were shared. I'm sorry we couldn't get through all the questions. We are facing many of the same issues. They're very complex issues. There are food security issues in many countries, and we have to find ways to deal with that. Find ways to deal with vaccination, surveillance, control, and what we're going to do, not only in the Americas, but worldwide with this virus as it continues to evolve and challenge our methods of eradication and control. I will also say that looking forward to expanding the discussion when we meet in Mexico City on April 20th and 21st. And that should be a good meeting with a lot more information and more time to go through this than we had today. Thank you all for attending. Thank you all for to the speakers. And Luis, most of all, thank you to you for all the work you do to put these things together with your staff. That's all I have to say. Thank you.
If could you put on the camera, we could take a photo. We have now 159. In the morning was 300. Now it's easy. we try to take a photo. I don't know the way to do it because I never understand why we could take a photo with 159 person by Zoom. But I suppose that somebody from my office will do it. I think so. Well, go ahead with the camera and then have a nice day and good afternoon to all. Thank you, Jacques, for your support. Thank you, really. Bye. Bye, Les. You wake up early.